Yes, sir, I'm hearing you, sir.
Yeah. So, Mr. 45 to be wait for 2 minutes.
Sir?
Should we wait for some more time?
Yes, sir.
Okay.
So shall we start, sir?
There are some 35 people. Is it okay?
Sir.
Yeah, you can start.
So, Gracial? Thank you.
Yes, sir. Can you hear me?
Yes, yes. Gracial?
Can we start?
Yes, yes, we can start.
So, yeah. Good morning, everyone, and I'm thoroughly pleased to welcome you all for the 9th session of the Faculty Development Program on Data Analysis using Econometric Models, organized by Department of Economics, Central University of Tamil Nadu, and sponsored by Atal Academy. So the topic for today's session is volatility model, which includes models like ARCH, GARCH, T-GARCH, and E-GARCH. Today we are having Dr. Ramachandran to handle this session. It's an honor for me to welcome you, sir, on behalf of the Department of Economics, Central University of Tamil Nadu. So Dr. Ramachandran, sir, started off his career as lecturer in Gokhale Institute of Politics and Economics, Pune from 1994 to 1997, and currently is working as professor in Department of Economics in Pondicherry University from 2006 to till date, with 23 years of teaching experience and 29 years of research experience. And he has received his PhD in monetary economics from University of Hyderabad. His area of specialization includes monetary economics, open economy macroeconomics, and applied econometrics. Sir has published numerous articles in different well-known journals. Some of the title of his working papers include Money and Inflation, Evidence from P-Star Model, work from Madras School of Economics, and Capital Controls, Exchange Market Intervention, and International Reserve Accumulation in India. A new approach to construct core inflation, also with Madras School of Economics in 2014. Among his most significant achievements includes being elected as Vice President for the Indian Econometric Society from 2014 to 2017. And Professor also received Merit Scholarship for PhD program in Pondicherry University, and has also received Best Student Award for overall academic performance in MPhil course in Pondicherry University. So now I give you Professor Ramachandran on speaking to lead.
Thank you, Mr. Salim, for
Thank you.
introduction. Thank you so much. At the outset, I'd like to thank Balaji for organizing this workshop. In fact, this kind of workshop was initiated a decade back in Pondicherry University, and it was a workshop on finance and econometrics for 1 week. And when Balaji was a student in this department, and he was assisting us to do that, that was the beginning of this kind of workshop. Subsequently, it received, significant, attention from the young scholars and participants. And through Indian Econometric Society, we had organized similar workshops all over the country. And this is what sort of those varieties. Okay? And see, actually, is asked this, what is it? This volatility model itself requires a workshop, exclusive workshop for 1 week to have a comprehensive understanding of the subject. Okay? But Balaji has given me, one session to speak on that. So obviously it is going to be very, very elementary and basic introductory lecture on the volatility modeling. And I don't use, PPTs. I use whiteboard and marker and teach as I'm teaching my MA students in my class. And dear participants, you don't hesitate to stop me if you don't follow me. After there are a lot of questions, okay, we can interact towards the end of the program. But you are most welcome to, stop me when you in the lecture also. You can stop me if you don't follow the lecture. And I'll try my best to make it as simple as possible. I will topic is slightly technical. And now where is not. See, I think most of you must be familiar with the utility of the application in which the measure of volatility is being extensively used. In most of the markets, the measure of variance, the second moment of the data, variance or standard deviation, okay, becomes an important variable. Okay? So, but how do we construct that? That's a basic question. Okay? Generally, how do you measure the variance? Variance is measured like, say, if it is a variance from 1 to n, xi minus x1 square. Okay? So variance. So if you take the square root of it, it becomes standard deviation. This is second moment of variance. What actually it measures? The dispersion of actual data from its mean, long-term mean. Okay. Here the mean can be either unconditional long-term mean of a data or conditional mean. Okay. It can be either of these two. Now, when you construct the variance, it could be for cross-sectional data. So, for instance, suppose you take 500 households income in a particular region. You want to collect the data information, household income. Okay. Now, this will have a mean and this will have a variance. The variance here measures to what extent the individual household's income is dispersed. Okay. So, in the extreme case, if the income across all the households are the same, the variance is going to be zero. And because the dispersion is zero. Okay. And now, similarly, the measure of variance used in econometric models. Suppose if you want to estimate an export demand function. In the export demand function, the variance of the exchange rate return that provides a measure of market risk of doing business with export. Okay, becomes an important variable. Hello. Yes. Now, what can I do actually? Now, this is what I am doing with the G sort. Balaji. Hello.
Sir, yes, sir, I'm hearing, sir.
See,
Hello. Sir. Sir. Sir, சொல்லுங்க sir. Okay, sir. Board is visible, sir. இப்போ board close ஆயிடுச்சுங்க, sir. Hello. Hello. Sir. 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 சொல்லுங்க சார். மகேஸ்வரி கால் பண்ண சொல்லுங்க. எனக்கு ஆனா கிளியரா தான் சார் இருக்கு. அவங்க சில பேர் மொபைல்ல கனெக்ட் பண்ணிருப்பாங்கன்னு நினைக்கிறேன் சார். ஓகே சார். இல்ல சார். இப்போ நீங்க மியூட் ஆயிருக்கீங்க சார். இப்போ எனக்கு கிளியரா கேக்குது சார். நீங்க பேசுறது. ஃபோன்ல நீங்க இருக்கிறது கேக்குது சார். சார். இல்ல சார். ஆக்சுவலா வந்து பாத்தீங்கன்னா, அவங்க எல்லாரும் அன்மியூட் பண்ணிருங்க. ஏன்னா பேசுறப்ப நாய்ஸ் வருதுன்னு சொல்லிட்டு அவங்க எல்லாரும் மியூட் பண்ணிருக்கேன் சார். அவங்க ரெஸ்பாண்ட் பண்ண முடியாது சார் இப்போ உங்களுக்கு. ஏன்னா அவங்க நடுவுல பேசிட்டே இருப்பாங்க நெறைய பேரு. அதுக்காக அவங்கள மியூட் பண்ணிருக்கேன் சார். நான் இங்க ஹோஸ்ட் வந்து மியூட் பண்ணிருக்காங்க சார். நீங்க மட்டும் தான் பேச முடியும். கொஸ்டின் அவங்க பேசி முடிச்சதுக்கு அப்புறம் தான் உங்களுக்கு ரெக்கார்ட் ஆகும் சார். ஏன்னா அவங்க நடுவுல நடுவுல போவாங்க வருவாங்க. அந்த உங்கள டிஸ்டர்ப் ஆகுன்றதுக்காக அவங்களோட ரைட்ஸ வந்து ஆடியோ நாய்ஸ க்ளோஸ் பண்ணிருக்கேன் சார். அவங்க சாட் பாக்ஸ்ல போஸ்ட் போஸ்ட் பண்ணிடுவாங்க சார். ஃபைனலா முடிச்ச உடனே நம்ம பதில் சொல்ல வேண்டியது. நடுவுல நடுவுல டிஸ்டர்ப் பண்ணாத உங்க ஃப்ளோ டிஸ்டர்ப் ஆகும்ல சார். இல்ல சார். இப்ப எதுவும் போஸ்ட் பண்ண மாட்டாங்க சார். ஹோல்ட் கடைசியா தான் சார் பண்ணுவாங்க. நீங்க பிரசன்ட் பண்ணுங்க சார். முடிச்ச உடனே நம்ம இது பண்ணிக்கலாம். நான் எல்லாரையும் நான் மியூட் பண்ணிட்டேன் சார் எல்லாரையுமே. உங்கள டிஸ்டர்ப் பண்ண மாரி இருக்குன்னு சொல்லிட்டு. வேற ஒண்ணும் இல்ல சார். 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 சரி. ஹலோ ஹலோ கேக்குதுங்களா? பார்ட்டிசிபென்ட்ஸ் இவங்க இருக்காங்க பாத்தீங்களா? தட் இஸ் வாட் அந்த பிரசன்டரோட வீடியோ மியூட் ஆயிடுச்சு. நம்ம சைடுல ஆன் பண்ண முடியுமா? பிரசன்டர் இருக்காங்கல்ல, பிரசன்ட் பண்றாங்கல்ல, அவங்களோட வீடியோ ஆஃப் ஆயிடுச்சு. நம்ம சைடுல ஆன் பண்ண முடியுமா? அன்மியூட் அவங்க தான் பண்ணணுமா? ஆனா இதுல மியூட் காமிக்கல. ஆனா வாய்ஸ் வரல, வீடியோவும் வரல. இப்போ நான் அன்மியூட் ஆல் கொடுத்துறேன்ல.
நீங்கள் டயல் செய்த எண் இப்பொழுது நெட்வொர்க் கவரேஜ் பகுதிக்கு வெளியில் உள்ளது. தயவு செய்து பின்னர் मुयற்சிக்கவும். के द्वारा डायल किया गया नंबर नेटवर्क कवरेज क्षेत्र के बाहर
சரி. சார் சார் நீங்க சாரி சார். சார் நீங்க ஒரு வெளியே போயிட்டு திரும்பி வரீங்களா சார்? அது ஏதாவது டிஸ்கனெக்ட் ஆயிடுச்சு நினைக்கிறேன். நீங்க ஒரு டிஸ்கனெக்ட் பண்ணி திருப்பி கனெக்ட் பண்ணுங்க சார். சரியா வந்துடும் சார். வேற ஒண்ணும் இல்ல சார். சரிங்க சார். இப்போ ஜி சூட் வேணா ஆரம்பிச்சுக்கலாம் சார். ஒன்றும் பிரச்சனை இல்லை சார். நீங்க ஜி சூட் வேணா அனுப்பிச்சுட்டு இருங்க. அதை திருப்பி அதை வேணா சொல்லிடுறேன் சார். நம்ம உங்களுக்கு அது கம்ஃபர்டபுளா பண்ணிக்கலாம் சார். சார் ஒன்றும் பிரச்சனை இல்லை சார். ஜி சூட் நம்ம பண்ணிக்கலாம் சார். நம்ம ரெக்கார்ட் பண்ணிக்கலாம் சார். அப்படியே ஒன்றும் ப்ராப்ளம் இல்லை சார். நம்ம உங்க இது ரெக்கார்ட் அனுப்பிச்சு விட்டுருங்க. அப்படியே எல்லாருமே இதுல கூகுள்ல கனெக்ட் பண்ண சொல்லிடுறேன் சார்.
என்ன பண்றதுன்னு முதல்ல பாத்துட்டு
ஒரே நிமிஷம் சார். ஓகே சார். நான் டெக்ல கேட்டுட்டு அப்படியே உடனே மாத்திக்கலாம் சார். ஒன்றும் ப்ராப்ளம் இல்லை சார். ஒரு ஹாஃப் அன் அவர் லேட் ஆனாலும் பரவாயில்ல. நம்ம அதை பண்ணிக்கலாம் சார்.
create a G shoot and let me see whether it can be done. Okay.
ஓகே சார். ரைட் சார். ஹலோ. ஒன்றும் இல்லைங்க. அவரோட சைட்ல ஏதோ ப்ராப்ளம் ஆகுது போல. இது கரெக்டா கனெக்ட் ஆகல. நம்ம இப்ப ஜி சூட்ல ரெக்கார்ட் பண்ணலாங்களா? அவரு ஜி சூட் இதை யூஸ் பண்றேன்னு சொல்றாரு. வேணா அந்த லிங்க் கொடுத்து பாத்துக்கலாமா? சரியா வருமா? கேக்குதுங்களா? சொல்றது கேக்குதுங்களா? என்ன சொல்றேன்னா, இப்ப ஜி சூட்ல பண்ண முடியுமான்னு கேக்குறேன்.
ஒரு நிமிஷம் சார். கொஞ்சம்
சார் சொல்லுங்க சார். சார். சார் சொல்லுங்க சார்.
I have done, actually it is asking me to add others. அந்த இது meet google.com-ல போயிட்டேன்.
சார்
REI
ஒரே நிமிஷம் சார்.
ஜாயின் பண்ண முடியுமான்னு பாருங்க.
ஓகே, ஒரே நிமிஷம் சார் ப்ளீஸ். லோட் ஆகுது சார், 2 minutes. இல்ல சார், ஒண்ணும் இல்ல சார். நீங்க அந்த லிங்க் கொடுத்துட்டீங்கன்னு வச்சுக்கோங்க சார். உங்க கூகுள் மீட்டோட கோட் இருக்குல்ல சார், அதை கொடுத்துட்டேன்னா அதை வந்து யாரும் ஜாயின் பண்ணலாம். அந்த கோட் மட்டும் சொல்லுங்க சார்.
meet.google.com hyphen
சார்
அதுல இருந்து இந்த கடைக்குல
REI சார் NADK இல்ல சார், MJDK. ஓகே சார், ஐஃபன் YAU. ஒரே நிமிஷம் சார், இது மட்டும் நான் இது கனெக்ட் பண்ணிட்டு உள்ள போயிடுச்சுன்னா போதும் சார். ஒரே நிமிஷம். ஆமா சார், கூகுள் மீட் தான் சார். உள்ள ஜாயின் ஆயிட்டு இருக்கு சார். சார் உங்க லாஸ்ட் லெட்டின் கேக்குது இல்லைங்க சார்? ஆமா சார். ஓகே சார், இந்த லிங்க் நான் உங்களுக்கு அனுப்பிச்சு வச்சுக்கோங்க சார். அவங்க ஜாயின் பண்ணிக்கலாம் சார். இன்னொரு செஷன் மட்டும் முடிச்சுக்கலாம் சார், ஒன்றும் பிரச்சனை இல்லை சார். போர்டு அந்த பிரசன்ட் இருக்கும் சார். கீழே அந்த ஒரு பிரசன்ட் ஒரு ஐடி, ஒரு கை மாதிரி இருக்குல்ல சார் கீழே, அது பக்கத்துல ஒரு இது இருக்கு பிரசன்ட் டவுன் சொல்லிட்டு, அதை கிளிக் பண்ணிட்டீங்கன்னா எதுன்னு கேட்கும் சார். இவர் ரெண்டே ஸ்கிரீன் கொடுத்துட்டு ஸ்கிரீனை வந்து இதில் கனெக்ட் பண்ணிட்டீங்கன்னா வந்துடும் சார். அவ்வளோதான் சார். சார் ஒரே நிமிஷம் சார். சார் கேக்குதுங்களா சார்? இல்ல நீங்க போன்ல இருக்கீங்களா சார்? ஒரே நிமிஷம், போனை கட் பண்ணிடுறேன் சார். அப்பதான் இதுல கேக்குதுன்னு தெரியும் சார். ஒரே நிமிஷம் சார். சார் கேக்குதுங்களா சார்? ஹலோ. எனக்கும் பக்காவா இருக்கு சார், ஒன்றும் பிரச்சனை இல்லை சார். சார் சார்
யார் இருக்கிறார்?
ஒரே நிமிஷம் சார், ஒரே நிமிஷம் இருங்க. ஒரே போட்டு வந்துருச்சு சார். ஓகே சார். ஓகே சார், ஓகே சார், தேங்க்யூ. ஓகே சார், ஃபைன் சார், தேங்க்யூ. இப்போ சொல்லுங்க. இப்போ ஆக்சுவலா அது அங்க சூட் அவருக்கு இது கனெக்ட் ஆகலைங்க. அவருக்கு அவர் என்ன சொல்றாரு, ஜி சூட்ல பண்றேன்னு சொல்றாரு. நம்ம அதை ரெக்கார்ட் பண்ண முடியுமா? இதுல இல்ல உங்களுக்கு தெரியாது, லிங்க் அனுப்புறேன், அதை ரெக்கார்ட் மட்டும் பண்ண முடியுமா? நம்ம பண்ண முடியாதுல்ல சார். வேற ஏதாவது ஆப்ஷன் அவர் சைடுல ஆடியோ வரவே இல்லை சுத்தமா. இல்ல எப்படி அனுப்பிச்சாலுமே அவருக்கு வந்து ஆடியோ ஒர்க் ஆகல. ஆக்சுவலா வந்து பாத்தீங்கன்னா ஒரு ஹெட்போன் யூஸ் பண்றாரு, ரொம்ப லோவா இருக்கு, கனெக்ட் பண்ண முடியல. அதுக்கு தான் பாக்குறேன். ஜி சூட்ல கிளியரா இருக்குங்க. ஓகே ஓகே. அதுல போயிட்டு அவங்க வந்து மைக்ரோஃபோன் இருக்கும், அதுல வந்து சேஞ்ச் பண்ணாம இருக்கும். ஆடியோ செட்டிங்ஸ்லயா? ஆமா சார். அதுல வந்து அவங்க ஹெட்போன் கொடுக்க சொல்லுங்க சார். எதுல சொல்றீங்க? இல்ல ஆக்சுவலா சார் ஹெட்செட் தான் கொடுத்திருக்காரு. அதுல எதுல சொல்லுங்க, திருப்பி சொல்லுங்க. ஒண்ணுல சார் அன்மியூட் இருக்குல சார். ஓகே. அதுல ஆரோக்கி இருக்கா? ஓகே. இல்ல சார் ஜாயின் பண்ணிட்டாங்க. இப்போ பசமா கனெக்ட் பண்ணிக்கலாம். உங்க செஷன் விட்டு ஏதாவது பாத்துக்கலாம். இல்ல சார், ஒண்ணும் பிரச்சனை இல்ல. ஒரு 2 செகண்ட் தான் ஆகும். அதுல போயிட்டு ஆடியோ செட்டிங்னு இருக்கும். ஓகே. ஆடியோ செட்டிங்ல மைக்ரோஃபோன் இருக்கும். அதுல வந்து அவங்களோட ஹெட்போனை மாத்திக்க சொல்லுங்க, அவ்வளவுதான். ஒரே நிமிஷம் இருங்க. ஒரு நிமிஷம் லைன்ல திருப்பி சொல்றேன். நீங்க மியூட்ல ஆடியோ செட்டிங்ஸ்ல ஓகே அதுல வந்து ஹெட்போன்ஸ் இருக்கணும். இருந்துச்சா கரெக்டா இருக்கும்.
ஆமா ஹெட்போன்ஸ் இருக்கணும், மைக்ரோஃபோன் இருக்கணும்.
ஓகே ஒரு நிமிஷம். ஓகே இப்போ
மைக்ரோஃபோன் ஆமா சார்.
சார் இதுல டிஃபால்ட் மைக்ரோஃபோன் தான் இருக்குங்களா சார்? நீங்க எதுல சார் கூகுள் செட்டிங்ல சொல்றீங்களா சார்? ஓகே ஓகே சார் ஒரு நிமிஷம் சார். அப்போ அதுதான் சார் இவங்க தான் சார் ப்ராப்ளம். ஐபன் ஆக்சுவலா அது வந்து டிஃபால்ட் மைக்ரோஃபோன்ஸ் தான் இருக்கு. அது ஏதோ ப்ராப்ளம் தான் நினைக்கிறேன். நான் மீட்ல எடுத்துக்கிறேன் விடுங்க. ஹலோ ஐபன் கேக்குதுங்களா?
சார் ஆக்சுவலி செட்டிங்ஸில் ஸ்பீக்கர் அண்ட் மைக்ரோஃபோன் அதில் ஹை டெஃபினேஷன்ஸ் ஆடியோவில் நீங்கள் அப்ளை பண்ணணும். ஆக்சுவலி அப்ளை பண்ணால் தான் ஸ்பீக்கரில் பேசுறது கேட்கும்.
இப்போ கிளியரா கேக்குது சார்.
ஓகே
சார் இப்போ நீங்க பேச ரொம்ப கிளியரா கேக்குது சார். சார் ஹலோ சார் கேக்குதுங்களா சார்?
நீங்கள் டயல் செய்த எண் இப்பொழுது நெட்வொர்க் கவரேஜ் பகுதிக்கு வெளியில் உள்ளது. தயவு செய்து பின்னர் முயற்சிக்கவும். आपके द्वारा डायल किया गया नंबर नेटवर्क कवरेज क्षेत्र के बाहर है. कृपया कुछ समय पश्चात प्रयास करें. The number you are
சார்
பழையபடி அதே ப்ராப்ளம் தான் பாலாஜி.
ஓகே சார் நம்ம இதுக்கே எடுத்துக்கலாம் சார். ஒன்றும் ப்ராப்ளம் இல்லை சார். நம்ம கூகுள் மீட்டுக்கே போயிடலாம் சார். ஒன்றும் பிரச்சனை இல்லை சார். நான் லிங்க் ஷேர் பண்ணிடுறேன். நீங்க ஜாயின் பண்ணிக்கோங்க சார்.
இப்ப நான் பழையபடி நான் வந்து அந்த லிங்க் சொல்லுங்க. ஒரு நிமிஷம் அது போனா சரியா வருமான்னு தெரியல. அந்த வரேன் ஒரு நிமிஷம். கோட் சொல்லுங்க.
REEI hyphen MJ DK D for Delhi sir. D for Delhi. K for Calcutta. K for Calcutta hyphen Y for Yeshwantpur. Y AU sir.
தெரியுதா?
தெரியுது சார். இல்ல சார் போர்டு வரல சார். உங்க வாய்ஸ் கிளியரா கேக்குது. போர்டு இன்னும் வரல சார். இல்ல சார் இவங்க ரெக்கார்ட் பண்றது வந்து இதுல கொஞ்சம் காம்ப்ளிகேட்டட் சார். நம்ம ரைட்ஸ் இதுல இல்ல சார். ஆக்சுவலா அவங்க வெப்எக்ஸ் வாங்கியிருக்காங்க. அதனால தான் சார் வர ஒண்ணும் சார். கேமரா மட்டும் வந்துச்சுன்னா போதும் சார். அவ்வளவுதான் சார். நீங்க முன்ன கேமரா கொண்டு வந்தீங்க சார் பிரசன்டேஷன்ஸ்ல.
வந்தது கிடையாது.
இது ரெக்கார்டிங் தான் சார் இஷ்யூ ஆக்சுவலா. யூனிவர்சிட்டி வாங்கியிருப்பாங்க சார். ஜி சூட் இங்க நம்ம வாங்கல சார். நம்ம இது வெப்எக்ஸ் வாங்கிருக்கோம்.
போர்டு வந்துருச்சா? போர்டு வந்துருச்சு, ஆடியோ பக்கவா இருக்கு. இது என்ன ப்ராப்ளம்? எல்லாரும் அந்த போர்டை ஷேர் பண்ணுங்க, எல்லாரும் ஜாயின் பண்ணுங்க.
Participants, all of you please use this link and join in Google. We have some technical issues. Please kindly bear with us. I shared a link, right? All of you are able to hear me? Participants?
Yes, sir.
I shared a Google Meet link. Okay. Please make use of that and join. Participants, please join, make use of that link I shared.
Yes, join Balaji.
Yes, sir. Some people are just now joining, sir. That's what I informing them, sir.
A lot of people are joined. See, the problem is I have to admit everybody, that's a problem.
Yes, sir. Everyone, please join in by making use of the Google Meet.
A lot of people have joined. Let me check with them whether some more people are there too. 45 people only joined.
So they will join, sir. Actually, they will. I will already post in the group too, sir.
Okay. No, Balaji, every time I have to admit that I was taking a join. That's why I'm just waiting.
Sir.
No, I hope. can ask.
Sir, almost 60, sir. So we can start, sir.
Yeah, again, around 50 people are joining. But let me check with them whether I'm not able to do that. Sundari, can you unmute your mic? Very good. So no problem. Now, my board is also visible to you, right?
Yes, sir. You have to make it presentable, sir. Big one, full screen.
This is what I have been telling you.
Sorry, sir.
Because I'm doing this for almost 1.5 years. Let me start first. Okay. Now, today's lecture is to understand how to model variance. Okay. Second moment of the data. Now, the variance could be either,
Arun Kumar, please switch on your mic. Arun, Ankur Jain. Ankur Jain.
Yes, sir. So please mute your mic, and when you want to ask some question, when you want to clarify some doubts, then you unmute your mic. Sit in a peaceful place, okay, so that there is no noise around you. Then you can raise your question, okay. As I told you, this is basically an introductory lecture because teaching Oshkosh model itself requires an exclusive workshop for 1 week, okay. So 1.5 hours, what I can do is I can give you some introduction in the context in which the Oshkosh models became very popular. Okay. Now let us say, suppose you have a time series data. Okay. Time series data is basically a record of a particular event over a period of time, and you want to measure variance of that. Okay. And the variance, the measure of variance has a lot of utility. Okay, it tells you the extent to which the actual data dispersed around its mean. Okay, around its mean. Okay, and it provides a measure of risk. Okay, if you take the standard deviation of the return of an asset, it provides a measure of risk. Okay, but we never had any mechanism of forecasting what will be the expected risk of holding. Okay, that information is very important while deciding your portfolio. Okay, while deciding your portfolio, investment portfolio, it is more useful if you can forecast the expected risk of holding various assets. So that means you should be in a position to forecast what will be the future risk. Okay, see, these are the this is one of the important things which was not resolved by econometrician till this particular tool was invented. Another important issue is, see, suppose you want to measure the variance of a time series data. Okay, normally the variance formula goes like this: I is from 1 to n. So it is. Xt minus x1 square. Okay. So what you get, the variance for a sample of period, one number. Okay, is basically the average. Okay, it's the average, or it is basically the long run variance of the data. Long run variance of the data. Now, suppose you have a data and you take a plot of the data. Okay, with respect to time. And let us assume that this is mu. This is a mean. Okay, this is a mean value. And suppose the actual data, suppose it's like this. The plot of actual data goes like this. Now, the spread of the data around its mean during this period to this period is large. And in this period, it is very less. Again, it becomes large. So when you take high frequency data and plot it, you are supposed to, you are, most of the time you get this kind of high frequency data means daily data, weekly data, intraday data, minutes by minutes data, okay, stock market data, interest rate data, exchange rate data. When you take the return of exchange rate, daily exchange rate return, daily stock price return, index return, when you take a plot of this, you are going to get this kind of pressure. Sometimes the volatility is more because the market is, you say market is highly volatile. Okay, and sometimes it's very calm, market is very calm, so volatility is very less. So understand, what does it mean? The distortion of the data from its mean, here it is large, here it is small, again it becomes large. So this is the actual picture. Okay, we call them as a short-term volatility. Okay, short-term volatility. And when you have a time series data like this, okay, you may not be able to take a variance which is constant. The variance here is varying. Variance is varying. Sometimes it is less, sometimes it is large. Then, how do we get a time varying? That means having one measure of variance for the entire time series data becomes irrelevant. Okay, so you need to construct a time varying variance measure. Time varying variance measure you have to construct. How do we do that? What is the conventional way of doing it? I'll tell you. How it was handled conventionally. Okay, now this is how you check. Okay, now you get a time series data. Time series data. And this time series data, sometimes, it is very high because you are taking the square of it. Very high, sometimes it is very low. Okay. And what normally people do is, you will get a time series data from the entire sample observation. Okay. Because for every observation, you will get a deviation and a square of it. Okay. Normally, what people do, they take the moving average of this to have a time varying measure of variance of the data. Okay. Now, how do we take a time variance? Moving average. Moving average means, see, for instance, you have time series data for a period of, say, daily data for a period of, say, 2 years. Suppose you fix in a window of, say, 25. Okay. What it does, it takes first 25 observation. Okay. That means it will become 1.25. N. Okay. First 25 observation. Then you will get a variance measure for first 25. Then you move the window. First observation to 25th observation. You construct a variance using this formula. Okay. And you get a value of variance. Then second to 26. Then you will get another variance. Okay. Sigma 2 square. So like that you move the window. Then third to 27. Fourth to 28. Like this you can move the window and get a time series data and the variance. And the variance measure. But what is the problem with this? Now you take the 25 observation, and when you take the average of this 25 observation, each observation is getting weight. This is nothing but the weighted average of 25 observation. What is the weight? Weight is 1.25. Weight is every observation is being weighted 1.25. Okay, all the past 25 observations. Now the problem with this is the variance in the immediate past, the variance in the distant past are given equal weightage. Okay, so in fact, immediate past should be given large weightage as compared to the distant past. Okay, that is how the market works. If something happens yesterday and it triggers volatility in the market, and it happens in the last week, it triggers volatility subsequently, there is no point in giving the same weightage, for the variance measure prior to the event that triggered the market, okay, to trigger the volatility in the market. Okay, so this is the major problem of using the moving average method to construct a time varying variance measure has its own defect. The defect is that all observations are given equal weightage. It is in the window size is 1.25. This is the problem. Okay, So immediate past should be given larger weightage as compared to the distant past. That's one problem with this method. But what you get, suppose you have the variance measure like this, the actual plot of the data goes like this, okay? You will get a variance measure like this, okay? A smoothened moving average means you will get at least this data will capture when the market is highly volatile, variance is rising. And when the market is less volatile, variance is falling. Okay, variance is falling. Okay, but the problem is this measure will have errors. Okay, see, this measure will have errors because all past observations are given equal. This is one problem. Second problem is how do we decide the window size? See, you give the same data for different researchers and ask them to construct time varying variance using the moving average method. Someone is choosing 20 as the window size. Someone is choosing 25 as the window size. Someone is choosing 30 as the window size. Okay? And they will get a time varying measure of variance for the sample of time series data. Okay? Now what happens is this fellow who chooses 20 as the window size will get a measure of variance for a sample, and this fellow will get a different measure of variance for the same set of data. It looks awkward. Okay, and this fellow will get another measure. Okay, for the same set of data. So the choice of the window becomes arbitrary. How to choose the window? Is there any mechanism by which you can choose an optimal size of window? Okay, so that everyone get the same measure of variance for the sample of data. Okay, for the time series data. Okay, so these are the problems with using moving average method. Okay, to construct time varying variance process. So this is the disadvantage with this method. Another important thing that I would like to highlight is suppose you have a model that say yp equals to say alpha 0, alpha 1, yp minus 1 plus epsilon. Or you can just put a simple model of x. Okay. One of the most important assumption when you want to estimate this model using the conventional econometric tools like OLS method, the variance of epsilon p is constant. Or the errors in this model are homoscedastic. Okay, and if it is not, okay, that means the expectation of epsilon p square is constant. Errors are homoscedastic. Okay, because this assumption is very important when you want to test a hypothesis that null hypothesis here alpha 1 equal to. I have to draw the inference. Okay. Instead, suppose if the variance is not constant,
Welcome, Dr. Suresh. Hello, Suresh.
Thank you, Balaji. Dr. Balaji.
Yeah, Suresh, just sorry for the inconvenience. Actually, the session was just now over because we have some technical issues. Ramchandra sir just now finished the session, so participants will join in another 5 to 10 minutes. Please bear with us.
Okay, fine.
We can cut down the session to maybe 1 hour, 1.5 hours like that. Okay, no need to proceed for 2 hours, right?
If it is early, also fine.
Okay, that's good. Just now they left, so I'll ask them to join very quickly because they need some time.
Okay, fine.
So, how the things are going on?
Fine.
Good. Okay, Suresh, give me some 5 minutes break. I just
Okay.
want to call the resource person. I'll get back to you. Okay.
Fine.
Hello, sir. Sir, voice is not audible, sir.
Hello?
Sir, I think session has not been started so far. It's not started. It's a break.
Yes. Who's this?
Yeah, it's Dr. Nimla Joshi. Says, shall we start now?
Yes, ma'am. Actually, we'll wait for a few more minutes. Resource person has already joined.
Yeah.
So just wait for a few minutes. My time is 11:58. Let's start with 12 o'clock. Okay.
Okay, sir. Fine.
Because people are left. So let them take some break. Ma'am, is it okay for you? I think you are very eager to have a session on GARS models. I don't know whether it's fruitful for you or what. Nirmala, ma'am?
Yes, sir.
Yeah, whether it is okay because of technical issues, we have certain.
No issue, sir. No issue, sir. Take your own time. It's fine.
No, it's fine. No, actually, I'm asking about a session because of some confusions.
Session was good, sir. And after that, we switched to Google. So then the voice was very clear. And when we have pinned it so that whatever he was writing on board, it was visible. Otherwise, earlier it was not visible. What was he writing on the board?
Yeah, the problem is with this WebEx. I don't know what happened. Sir is not able to access that. So unfortunately, things are messed up in the beginning.
The only thing was that he has focused too much on the derivation, that how he has arrived. There may be some in this group, there will be many research scholars. So if he would have, last he has taken the example of the winning and losing of the game. So these are the simple examples. So he would have used that now, so immediately he could have get the connect from the audience.
The problem is, see, the arch cache models, no, ma'am. Generally, people used to estimate in just like that. Okay, it's available in EVs. It's in a very handy manner. So without knowing the logic, if you
Yes.
if you ask anybody to estimate variance equation, they will simply do it. It's very simple actually to getting done in EVs. But the
Yes.
problem is the theory part. As I said, I'm working this arch cache model for the last 15 years. Okay, since my PhD. But still, today's lecture is new for me.
Very true, sir. Very true.
That is one. So the
Because-
logic matters. What is conditional variance, what is variance, then why we have to model it, what is auto regression, kind of things are very important. So generally, sir is used to cover only the basics. If you got that, we can easily do the things because as he rightly pointed out, there is more than 100 types of class of models are there in Arch Cache. So people can, without knowing the basics, they can pick and estimate the models. That is what these people are always covering the basics. If you have strong in basics, rest of the models will follow you. That is the logic here.
Yes, sir. Normally, what happens in whenever we are sitting for these type of sessions, so people will just take the data set that this is the share prices, and then they will explain with the data set. Okay, this is the way we have arrived at this. This is the outcome, and this is the application of it. Yeah, the first time I have actually I was paying attention on the derivation, that this is the way what is the logic behind the formula which we are using and how they have arrived on this. So really.
Yes, ma'am. Why sir is teaching in this way, ma'am? Suppose if you want to include something in the Arch-Cache models, if you know the logic, you can estimate your own without relying on any packages. That is what it's all about.
Yes.
If you go with some advanced models like asymmetric Gash models and then smooth transition model, you can't estimate it in these packages. You have to write your own codes. Unless until we are not aware of what is happening in that model, it's quite complicated. We can't do any analysis.
Very true.
That is what Sir Raja sir and all, they used to understand the model. They used to write their own codes. They try to estimate it through stimulations. That is their strength actually.
Actually, that is the expertise only. Because see, I remember I was once in a session. There was, again, this was an FDP, and the resource person, he simply said, he was explaining the correlation and what is the significance of the correlation, how to test it.
Oh.
So he just made one comment, if your correlation value is coming, and he was teaching that how to get published in Scopus or ABDC papers. Okay. So he said, if it is coming more than your alpha value, it means your hypothesis is tested and approved, and you can go ahead with this. How can you tell like this? Because you have to look into the factor, and there are so many other things which you have to look into. If your R value is coming like this, he said no, all people are accepting the papers if you are having your R value like this. So that actually gives a very bad taste to researchers.
Obviously, ma'am.
Here, when sir explained, so I could figure it out that yes, as a researcher, you have to deep dwell into the concept, understand the why it is happening like this. Then only you can arrive at the solution. Otherwise, it's just a mere exercise that okay, you are putting the formulas and you are arriving at the solution and commenting on the basis of solution. That's not fair.
Actually, sir is a president of TICE, ma'am. I think you know about the Indian Economic Society.
Yeah.
He's a president of TICE now. Bhanumudi sir is a secretary, actually. These people are always working with the data. That's what we try to pick scholarly persons on this field, actually. He's
Yes,
my
sir.
guide, actually. He's my PhD guide, actually. I work under him only.
So, yes, it gives you in-depth insight about the subject. That is very important, sir. And nowadays, there are very few people like that. Very few.
But the only thing is, unfortunately, in the morning, there are some messed up happened. So I completely regret for that. So few things we can't.
But
it's
that's
beyond our
fine, sir.
control.
After that, we enjoyed the session. That's okay. So ultimately, the end objective was actually achieved. So the learning was there, and we have learned a lot.
Okay, ma'am. Thank you.
The request to please share the video of the session because
the problem is that please all of you kindly understand my constraint. Actually, in my department we have a frequent power loss. Okay, so I asked my IT sections to record it. They recorded from the morning 9 to 7 o'clock. Not only this program. So we can't ask them to supply the videos every day. Okay, once every session is over, they can go and edit it because just imagine 7 hours of high quality video. How much MBs it will took. Okay, I can't share it via any mode. So even though you left the class, that things are getting recorded. So what is the point in sharing that things? We have to go for an editing. Okay. So if people are asking videos and they think that I might have hide it, it is not for me. It's for you people only. Okay. So you understand our constraints also. We have to get the videos from them with the high quality hard drive. Then we have to edit it. Okay. So don't think that I'm just simply hiding the things from you. I'm not getting it. So it's keep on recording another session. Practically what I'm saying is it is not possible to share the videos within the sessions. Okay, once it's over, I can share it on the YouTube and I can give the link. You can make use of it. Okay, you know how much space it will take. Okay, just try to understand. Second thing is you are keep on asking PPTs. I already requested to people. They will only very few send it. You just understand one more thing. There are 200 participants are registered. Okay, only 120 are here. I can't share the materials to everyone who is not attending. If that is the case, they will attempt the exams without attending here. That's maybe the problem. So I will share the Google form with you. Those who present, you fill it. I will mail those things to them only. One more thing is most of the participants presenters not ready to share their PPTs. It's their copyright. Okay. They can share PPTs with some other form. I'm requested them already. If they share it to me, I can share on that moment itself. So please try to understand. People are asking, there is no scope for sharing PPT and all. One more thing I strongly believe is that it is not the PPT matters. What you attend, what you learn matters. Okay. Don't think too much about your exams. It is not your certificate is a product, end product. It's you. What you learn is matters. Okay. Just try to understand that part. You look at the group, the people keep on asking PPTs. Do you think that I'm just going to keep it with me? It's for you people only. Okay. So please try to understand our difficulties also. Videos, I'm very sure that it's not possible for me to share within the program. I can, but definitely I'll share you once I get the edited version. Maybe in the YouTube channel, I'll give the link. You can follow it and make use of it anytime. But this part, I'm completely fed up actually, exhausted. People keep on asking PPTs and keep on arguing certain things. It won't be fine. Okay. Yeah, regarding our test, I think you people are thinking very seriously about your test. It's the MCQs. Okay. I'm going to pick maybe 2 or 3 questions, maximum 30 questions from all the 14 sessions. Okay. So MCQs, if you attend the sessions with full attentiveness, you can easily fill it up. There is no need to write pages and pages. It's only MCQs to Google form. Right? Any questions? I think the resource person is waiting. I'm taking his time. So I will ask Dr. Suresh to take the session. Who is Prakash? Are you here?
Yes, sir.
Yeah. Switch on your video and just.
Sign, yes.
Prakash?
Sir. Yeah, very good morning and welcome to the fourth day of online FDP data analysis. We have with us today Dr. Suresh Nayak sir to handle this session. It's an honor for me to welcome you, sir, on behalf of Department of Economics, Central University of Tamil Nadu. He has started off his career at the Central University of Karnataka as an assistant professor in the Department of Economics, and he has also worked in research institute like Center for Economic and Social Science, Hyderabad, as a project associate for a different project. He has received his PhD in economics from School of Economics, University of Hyderabad. He has published numerous articles in the field of banking and finance, human capital, and FDI, and he has presented papers in both national and international conference. He is currently working as an assistant professor in the Institute of Insurance and Risk Management, Hyderabad.
Yeah, Prakash?
Sir, are you hearing, sir?
Yes, Prakash. Carry on.
He has presented papers in both national and international conference. He is currently working as an assistant professor in the Institute of Insurance and Risk Management, Hyderabad. Now he is taking this session.
Yeah, Dr. Suresh, please.
Thank you, Balaji. Just a minute, I'll share my PPT. So good afternoon to all. So today I'm going to have a discussion around, I take around 45 minutes to finish it up. Then I just give simply that the data, how we can frame an equation in this data file and run XT bond to estimation in the data file. How do we get result? All these things. Okay. The first thing is that when we speak about
आधे मैं लिखती हूँ आधे आप लिखो खत्म करते हैं बाकी सब उसमें लिखा हुआ है
All of participants, please switch on your mics.
So, especially if you talk of dynamic panel model, it's basically most of the economic relationship involves dynamic adjustment process. So here, when we talk about dynamic panel model framework, is very much initially started with the labor economics, development economics, and macroeconomics. So one of the reasons is that why this panel data model became very much famous in the recent years is that because the inclusion of the lag dependent variable as a regressor provides a dynamic adjustment in econometric model. So by construction, the lag dependent variable, by inclusion of the lag dependent variable on the dependent side, is always correlated with the cross section specification effects, and it created the problem of endogeneity appears in the model. So this endogeneity issue suggests that the least square bias estimator may be inconsistent in the model. So as a result of that one, the authors like Alessio and all these authors, they suggested the use of instrument variable method or the generalized method of movement, which is a better estimator, which gives the producers consistent parameter estimate for the data with finite time periods and the large cross-section dimension. So among them, the system GM estimators has been very popular because these GMM estimators provide the better inferences where using the minimal set of statistical assumption. So this unit, these things, we focus on the issue of the dynamic, the panel data model. So here, one thing over a period of time, there has been the more research is done in this area. A lot of new estimation has come up, but among them, the system GM estimator has been one of the better estimator compared to the other estimators like instrumental variable, the panel data estimations. It is a process where now the system GMM estimator has become increasingly popular. So as a result, why it is popular is because it gives the better inferences by just using the minimum set of the statistical inferences. Okay, so we'll start why this among this one is that the Arlino-Bond estimators. So unlike the statistical panel model, the dynamic panel data model includes the lagged levels of dependent variables. For example, if you write the equation, the yt is equal to yt minus 1, where we have the lagged variable of your dependent variable on the right side. As a result of that one, what happens is that including the lagged dependent variable as a regressor violates the strict exogeneity problem. So because of this lagged dependent variable, there is always a chance of that the lagged variable will correlate with your random effect and your ui and vi in the equation. So that I will show you the later part how this equation can be affect your exogeneity problem in the model. So first, this Arnold-Bond estimators. This estimator basically is generalized method of movement used to estimate, as I told, that used to estimate the dynamic model of panel data. First, it was proposed in 1991 by the Manuel Arlino and Stephen Bond, based on the earlier work of Alok Bhargav and John Dennis Sargent in 1983 for addressing certain endogeneity problem. So GMM system estimator contains both the levels. The first difference equation, it provides the alternative standard, the first difference GMM estimators. So then it was that the Anderson and Assio in 1981 in their paper, they proposed the solution by using the instrument variable estimation. However, the Anderson-Assio estimator asymptotically inefficient because as it is asymptotic variances where variances were higher than the Arlino-Bond estimators. So as a result of that one, similar set of instrument, as a result of that one, the generalized method of movement estimation was better than the instrumental variable estimation. It's like when they found that instrument variables are, wherever we run the instrument variables equations are, they were less efficient in terms of compared to the GMM estimation. So again, the Arlino-Bond method, the first difference of regression, whenever we had this problem of instrumental equation, so the Arlino-Bond suggests that the first differencing of your equation can eliminate individual effects. So when this can solve your problem of individual effect, then why we should approach the instrument variable? So then the deeper lags will help us in terms of giving the better results compared to the instrumental variable. Okay, so the first differencing is a way where you can eliminate the individual effect in the equation model. So in the traditional, especially if you go back to this traditional panel data techniques, adding the deeper lags of dependent variable. So what used to happen is that by differencing, we used to lose the number of observation. So as a result of that one, in the final, we used to have the less observation for the analysis. So for example, we have, if observation are t time periods, then after the first differencing, only t minus 1 lag are usable. So then if the k lags of dependent variables are used as an instrument, again t minus k minus 1 observation are usable in the regression. So this creates a trade-off. Adding more lags provides more instrument but reduces the sample size. But in the case of Arlino-Bond estimation, this problem was taken care because given the less assumption, we used to have the more observation for more sample size for our analysis. So this is where the GMM estimation of the Arlino-Bond became a very famous, because we are not losing any observation due to the differencing. As a result of that, we have the more instruments to handle this kind of a problem. So as a result of that one, the GMM Arlino-Bond estimation became the one of the popular model to solve the endogeneity problem in the equation. So here we can just start with the equation, where how these equations are framed and how this individual effect and the general error concepts can be overcome. So especially many economic relations are in are dynamic in nature. So one of the advantage of panel data is that they allow the researchers to better understand the dynamics of adjustment. So these dynamic relationships are characterized by the presence of lagged dependent variable among the So that's what we can put equation where we can see that in this equation where yit, the delta yit minus 1, this is where we can see that you have the lagged variable of your dependent variable. Because of this one, this is related to your UIT. So as a result of that, the individual effects. So if you overcome this UIT, because of this one, there is a high correlation of UIT. So that's what where your delta is a scalar of xit. That follows the 1 into the 1 into k matrix, and again we have the beta which is follows the k into 1. So here UIT, which is a one-way error component model due to the presence of your presence of your what you call lag dependent variable. So here the one is that the identical independent distribution, that's what UI follows your 0 and standard deviation. So this one, so as a result of this one, the dynamic parallel data, which was 8.1 and 8.2 equation, is characterized by two sources of persistence over time. One is that autocorrelation due to the presence of lag dependent variable among the regressor. That's what the YIT delta YIT minus 1, that is where the problem of autocorrelation. And as a result of this autocorrelation problem, the individual effect characterizing the heterogeneity among the individual, that is what your IIT, where it is not observable, that will have creating a lot of problem in the equation. So let's start off with some of the basic the problems in terms of introduced by the inclusion of the lag dependent variable. So once we know that since YIT is a function of UI, that is the error, it immediately follows YITI minus 1 also. So is also function of UI. Therefore, YITI minus of the right hand regressor of 8.1 equation, that is what is correlated with the error term. So this renders the OLS estimator biased and inconsistent even with the PIT are not serially correlated. So as a result of this one, the alternative transformation which we can overcome this one is that that's what the Andrew and Hasio, they said that what we can do better is that the alternative transformation that can overcome this individual effect, so that we can overcome through the first difference transformation. So in this case, when there is a first difference transformation happens, that is what the change in YIT divided int is equal to the change in YITI minus 1. So if you do the first differencing, in this case what happens is that the correlation between the predetermined explanatory variable and the remaining error is easy to handle. So that's what that's where the Anderson SEO paper came to the picture, which became very popular, and where he suggested that by doing this differencing in the, we can get rid of the individual effects error in the model. So this is where the instrument variable estimation method leads to the consistent, but as I earlier told that, but not necessarily efficient estimate of the parameter in the model, because it does not make use of all the available movement condition. We will lose some of the observation. As a result of the sample size will be getting limited, as it getting reduced. As a result of that one, it will have a lot of problems in the model. So one is that the RNL bond estimator to overcome the testing of over identification restriction, and they suggested that RNL bonds as the Sargent test for over identifying restrictions. So when we talk about this one, the RNL bond over identification restriction, basically this Sargent test has become very popular in terms of estimating your serial correlation in the model. If that test satisfied, then we can overcome the Sargent test. Okay, so this is where your P refers to the number of columns in W and the differencing of your V, denote the residual of the two-step RNL bond estimator. This test, especially if in the stata, we can use the command called eStata Sargent, and other tests are which are very much Hausman test in the same, and again is the two-step GM estimator, assuming that the disturbance level of MA0, MA respectively. So this these are the few estimation which we can check the same thing in your Stata model, where we can use this equation for analyzing your dynamicness in the nature. As a result of that one, we can see that hello, can you hear me?
Yes, sir.
Okay, fine. 1 minute, 1 minute. Hello.
Yes, sir. We can hear you, but we are unable to see your presentation.
1 minute, man. Problem is happening. Hello.
Yeah, it's now display, sir.
It's clear?
Yes,
Yeah,
sir.
it's clear, sir.
Okay, fine. See, this is can you see the screen?
Yeah, yes, sir. It is visible.
Okay, fine. See, here, so this equation YIT, delta YIT minus 1 is equal to XIT. Especially, I have taken a small data set, which I want to estimate the performance of bank over a period of time. So to measure the performance of banks, so we have taken the equation. We have taken equation where take an equation, the return on asset is our dependent variable. So the return of asset is dependent variable where it is depending on number of other factors. For example, we have taken a loan to total assets on mate. Just copy this one. Okay, so we have taken the different variables to assess the return on assets of the banking sector. So here we can see that there is a I dot ROA is the lagged variable of your dependent variable. Again, we have the loan to total asset and deposit to total asset, the growth rate of deposit, cost income ratios, and log total asset. These are different variables we have taken. So the same thing is that if you use the same equation in the panel data, can you see this do file? Can you see this do file, guys?
Yes, sir.
Yes, sir. Yes, sir.
Ma'am, this is a file which we have created. This is where we have one is that XT bond 2 equation, because in Stata we have XT bond 2. So if you install this XT bond 2 only, then only we can run the GMM model in the system. If you don't have that XTA bond 2 data in your if you don't install it, that's why in the Stata, if you want to install XT bond 2 data, just type SSC install XT bond 2. So once you find that one, you will able to understand, you can be able to install that data package into your data file. Without installing the XTA bond 2 data file, it is very difficult for you to get, very difficult to run in the state. Okay, so here, as I told you that my data file is the return on assets, as we have taken as my performance indicators. I want to assess how does my performance is depend on the loan of the total asset, that is your bank, the loan of the total assets, again the deposit of total asset, growth of deposits. How this, all this, again we have taken the macroeconomic variable like inflation rate in the system, again interest rate. Then we have the GMM equation, which is the instrument GMM equation, which we have taken, again lag variable here. Again we have the instrumental variable. Here we have taken, as the instrumental variables plays a very important role, but as in the theory they said that by having too many instrument, it can create a problem for your estimation. So that's why the Andrew and Hasso, they said that by running just instrumental variable, we can be overcome the endogeneity problem in the equation. But the system GM was better better estimation than the Andrew Asio instrumental variable estimation. So we have taken, there are different levels are there. No level, no difference, sergeant, robust, small. There's a different levels of test is there. If you take each individual one, we'll get a different result in the model. So just what I want to do is that just I'll take a small example of the same test. So here I have the data. It is from 2006 onwards to 2015. I have a data. So here I have a bank code. So I have all the datas of the banking sectors and all the banking sector data I have. So as a result of this data set, I want to show you that how the results will be how the results you can see it. Okay, first is that as I written here is a bank wise analysis. I have taken XT set, which we are setting up our data. We are commanding this data to take as a time series. So panel variable. So we have the panel variable bank code with respect to the time variable. Okay. So once I have already written the equation, just I'm copying this equation into the stata command. So if you copy this equation into stata command, we can see that so we have received here. What are the important things you should understand is that, so here the important things is that as in the equation we saw that this is a dynamic panel data estimation, that is one step difference GMM. So here we have all our variables in the panel on our results. We can see that among this, especially if you see that there are negative results with respect to in terms of our performance. One is the growth rate of deposits. Again, the income ratio, log to total assets. Again, loan loss ratio. Okay, as your loan loss ratio increases, it will be having the negative impact on the performance. And the industrial constant, this is industrial, different variables are there. But here, if we go downside, we have this annual bond test for AR1, the annual bond for test for. This is where one should be very cautious in terms of determining that whether it is your hypothesis is tested or not. So in both the cases, it is more than the 0.05. So as a result of that one, we can go ahead with this one. Again, we have the Sargent test here and Hansen test. So this is the result where, again, this is just one I'm telling. Again, if you, as I see that I have taken the different models here, because it is not a final model. We are working on the model where we find the actual better result taking into the consideration. So I have the other models also which okay.
Hello.
Hello.
Sir, I have a basic question regarding the ROA variable.
Okay, sir.
Sir, the ROE is the return on asset, and since we are considering a panel of different banks, the different banks can have different accounting policies to represent the ROAs.
Okay.
They may have different accounting policies, and therefore, if we are considering ROA as a variable, is it not correct to show aren't we assuming internally that all the banks are maintaining the same accounting policies?
Sir, as per the Basel norms, if I think you also aware of that one, is that all the standardization of the calculation of their ROEs, they are making it to one standards. So we assume that basically the ROE, whatever the data is given by the different banks, are much of there is no much variation in terms of estimation. That's what we heard from the bankers, is that again now many of the papers, international papers, uh, they take return on asset as a performance, return on asset one, and I have taken the return on equity also. If you see this, the second model, the XT bond is model 4. The return on equity also I have taken, because these two can represent the performance variable for the banks. Yes, estimation as per the return on estimation of each individual bank. I don't think that accounting standards of the each banks are so different, because ultimately the RBI will be looking into all this
No, sir, I am not saying accounting standards are different, but accounting policies might differ. Like say, if I am accounting for say inventory, one might follow a FIFO method and one might follow a LIFO method. They both are perfect. There is no and over the period of time, they are consistently also maintaining. Like if we are considering a panel, suppose for sake, I am saying that SBI is maintaining FIFO for from the very beginning and consistently maintaining that.
Yes, true, very true.
There is no problem. But if I consider that PNB is maintaining LIFO instead of FIFO, and it is also consistently maintaining that, but how aren't we assuming that they both are either using LIFO or FIFO in our in this analysis? Because if someone considers LIFO over the period of time and someone considers FIFO over the period of time, and we are comparing them, we are assuming that they are somehow in a same state.
So you mean to say that this can really impact our result?
Sir, I don't know exactly whether it would be impactful, but it might be taken into consideration. I think so, because they both are under accounting standards. You may follow LIFO, you may
Yeah,
follow FIFO
FIFO and LIFO,
of
they can
inventory.
follow.
They can follow, and they are consistently following over the period of time. That is also fine. But if we are comparing the cross sections, then it might get something different, because if we are making a cross-section analysis in a panel setup, we are assuming that they are somehow comparable. They are in a same state, I think.
Sir, may I answer this question?
Sure, ma'am.
Yeah, actually, say whatever doubt you are raising, Mr. Shantanu, that is applicable in the manufacturing. But as far as the banking sector is concerned, there are so much
No,
rules and regulations. Accounting policies are not impacting on the reporting to that
no, no,
extent.
that's
Small,
perfectly fine,
yes,
ma'am.
to some
That's the
extent is
perfectly.
okay. But
just a minute, please. Are you able to hear me? Let the resource person finish the lecture. Then we can have this discussion, because it's not wise to disturb this.
No, it's okay, Balaji. Let them, because
No, it is a literature. It is, they are talking about the methodological part, right? Actually, you are delivering a particular tool. They are talking about the literature and the theoretical part. So that can be taken care at the end of the session.
yes, sir, that is true.
I'll finish in 5 minutes. I'll finish in 5 minutes. Then we can have the
This is
session.
what I feel. If you have any issues on methodology on the research design, we can have a separate discussion, because it's a tool. Let us assume that tool works well. We are concentrating only on the tool. Maybe the data what we are using, yes, it matters, but that is a literature issue, theoretical issue. People may have different issues on the theory part. So let's resource person finish the thing, then we might have a discussion on it. Sorry for interpreting. Mr. Suresh, please carry on.
Okay, fine. So, Shantanu, we'll have a discussion on that. As Madam also rightly pointed out that much of this FIFO and LIFO may have the problem in the manufacturing sector, but as we know that majority of the banks are following certain standards, maybe that may not impact, but we'll have a discussion because that's a very good point which we can have discussion on that one. Fine. So here I'll take another 1-2 minutes, then I'll close this session. Okay. So here the one thing is that if you see this the modeling technique as we go on using the different models, especially 1 minute, I'll take some other piece from that one. One minute. One minute, just a minute. Can you just see the screen?
It's not.
Okay, fine.
Oh, sir.
Okay.
Yes, sir.
Okay, ma'am. See, that's what as this model we predicted, and I wanted to show the 3 comparison model between the panel data and the instrumental variable and this GM estimation, how the results will be differing. So if you see that the comparison between these 3 different models, we see that in the GMM estimation we have the better model, a better result compared to the other model. It will be more efficient than the instrumental variable model in terms of predicting the results. So that's why this JMM model has become a very prominent in the recent years, and many of the international researchers, even in India also, we are using this JMM model in terms of a labor economy, in terms of the development economy, where they want to assess this, how the dynamic nature in the system can be handled. So in this way, to overcome any kind of a dynamic natures in the model, so the GMM estimations can be the better model to estimate the dynamic nature. So I'll stop here. If anybody has any question, they can ask me now. I want to show you something else, but it's not coming.
That is the thing. For
Yes.
Yeah, sir, how to read this outcome? Can you explain it?
Ma'am, see, basically, ma'am, on wait, ma'am. Ma'am, especially as we discussed in the model, that here 4 things are there, ma'am. Here you can see that Arnold bond test is there. AR1 is there, is the first difference. It is 0.01. So this both should be more than the 0.05. Then only this model is perfect. Again, here you can see this model is not in the Sargent test of over identification restriction. We are seeing that it is 0.10. So there is a problem with the model. So it's both should be able to come 1-1, then only we can go for the model. So like this, what happens is that again the same thing, ma'am. This thing is that the result on loan to total asset, as we explain in the panel data. especially like how the loan to asset, especially if you see that growth of deposit is showing the negative sign in the model. What does it mean? Can we say that the increase in the deposit of the banks is a negative effect on the profit of the banks, or how do you assess this one? Again, a log to the total asset is there. As we see that again, the total asset is increasing, is showing the negative side. Means there is some kind of a problem in the, because as we know the deposits in the literature, as the deposit increases, we can see that the deposit can be used for the lending purposes. As a result of that one, we can increase lending purpose. As a result, the bank profit can go. And one more important variable which shows is that around the diversification, because we want to assess that whether the diversification of the banks, the diversification can really help the banks to increase their profit. So that's where we saw that the diversification is not helping it's like 1.36, p value is around 0. P value is around 0.24, means it is not significant. So as we see this one, the diversification is not a positive. But the loan loss reserve, which is one more indicator to assess the efficiency of the banks, it is a significant. Means if the loan loss reserves increases, it is a negative effect on your profit, and it's a loan loss ratio in negative. So as we can see that as we bring down our loan loss ratios, automatically the profits of the banks can be increased. So this is where again we have the industrial concentration, that is significant at 0.5 percentage. So keeping all this aspect, we can see that this model is not this model is not a perfect model in terms, because that's what we did other models also. As we go run other models, for example, if you run these other models, again the variation we can see in terms of the data. So this we worked, I'm just showing that how this can be again repeated to this one. So again, this is again we are getting the different results. So ultimately we are say again, if you see that the loan loss reserve is coming very significant compared to the other models. So this is where here we used the different techniques to get the final output. So ultimately we want to see whether the Sargent test is over identification is significant or not, the Hansen test is over identification is significant or not. If these two tests are not significant, then whatever the data we have received from this data, it is not valid. So we should try some more experiment in the data. Nirmala Joshi, madam.
Yes, sir. I got it, sir. It means first we have to see that whether these tests are giving us right results or not. Then we have to check the coefficients.
We order coefficient.
Yeah. Thank you, sir.
Rest of the things are same, ma'am. As we know in the panel, how do we explain this one?
Yes, sir. Yeah. Thank you.
Suresh, there are some. Yeah. Just a minute.
Sir.
Just a
okay,
minute.
sir.
Suresh, there are a few questions which is posted in chat box. You can answer the participants who is asking now. Then you can look about the.
Fine. Okay, how to choose a proper instrument variable? Yeah, this is a very interesting question. How to choose a proper instrument is that it's especially your instrument should not be more. Basically, the instrument should be such that it should not be correlate with your error terms. So that's why it's like we are using like we have many instruments we have taken. What we do is that we take first two, then we see that how the result is coming up. Again, we try with other instrument. By the error try and error meeting, then we find that if the results are better, we are going with that particular instrument. So it is a error and try methods we are using for instrumental variable.
Hello. Hello, sir. My name is Benito. Can I ask a question?
Yes, sir. Please, sir.
Please.
Yeah, I have a question on basic panel econometric analysis, like not specific to dynamic panel model, because I'm working on panel data and I'm getting low R square and adjusted R square. So how important is R square for accepting the model, and what is the limit of R square that we should be aware of?
Sir, what is your data size, sample size?
Sample size around the number of what I have will be approximately, I think, 10,000 or something.
Even if you have the 10,000 data set and you're getting R square very less.
Yeah.
That is a discontinued data.
Yeah. Because then there's a lot of problem with the data, because as we know that in econometric, we say that the higher the sample, the more efficient data set. But if you're only having the higher the sample, then your data set is not showing the significant, then I think you should recheck with your data. There's something is a problem with the data.
One more challenge with the data is that it has a lot of missing values over the years.
Yeah,
Since it
that's
is a
true.
20 years period data, so 20-year
Okay,
period.
okay. So that's what I'm telling you first. The first thing is that Benito, one is that you totally diagnose your data set first. You check the data set, check the missing values, check there is how much missing is there. There is a missing samples, it goes on increasing, then automatically your sample will not be the better one. And the second one, which I want to add, is that because now there is many international papers are coming, the researchers, and there is even a bigger question that we should trust R square or not square. So many are saying that it is fine, even R square is around 30 to 40%. Because that is also fine, but again it's a huge debate. You can check in Google that there's many papers on telling that the R square approximately around 40 to 50% is also fine, but it depends upon your data set. Basically, that's what you, as you rightly pointed out, there's a more missing value. Just take care of that one, then you rerun that model again, you see that there's any changes, or if there is no improvement, then I think you can go. What is R square you're getting?
Actually, there are two models. One model I'm getting around 20%, 30%.
Very less.
Other model
This
even
R
lesser
square
than
in
that.
the primary survey data is fine. If you collect the primary data, this R square is fine. But in terms of a secondary data, this R square is like it's very you should think once again.
Sir, also since this is my first time working with panel data and econometrics, you said diagnostics and certain things of the data should be checked, right? So can you just give an idea of what are the important things?
A simple thing is that when you get the data, you should start filtering the data. So what is the filtering means? Error in the typing. For example, you're typing the income data. Okay. So X person income is 10,000 rupees. You type 10,000. Okay. How do you find that one? So that you want to plot the data for all the variable. Plot the data. Okay. When you plot the data, you see that whether there is a continuity or not. Okay, first you do that one. Second one is that as you see that there is a lot of, especially if you just do a frequency in the data. Just if I type, say for example, if I type this just frequency in my data set, or describe my, just I type describe, I will get all my data here. Okay, so here you can see that what are my data or how the variables are there. Again, if you what is the frequency? There's one more equation. Frequency we can draw that descriptive of one minute, descriptive of PVT. Okay, so like this, you go on, you go on, check each variables. Okay, what is the sample size? Whether there is a more missing value in the particular sample, then you do one thing is that if there is more missing value in the particular sample, then it becomes unbalanced. So when you with your more unbalanced data set, then you are trying to run the balanced database, it doesn't work it out. So then that's a basic problem. So one is that check with your data, plot all the variables, check for the variances, then you check for missing value. Then once you clear all these things and make as a balanced data, then you run the model, then see whether it is your R square increases or not. First basic is the diagnostic of your data. If you don't do that one, then your data is waste.
So given the unbalanced, if I have an unbalanced data, and can I?
There are models where you can use unbalanced data set also. In the panel only, there is unbalanced data set where you can use it. Then
If
all the basic theories will be eliminated.
Okay, so if I'm using unbalanced, what are the important considerations I should be having?
And there is no consideration, you can go ahead as per my understanding. You can go ahead, no problem. You can do it. The same thing will be applied for there also.
All right. Fine, sir. Thank you.
Thank you, Benito.
Thank you so much.
Somebody is asking a few questions, Suresh.
Yeah. How to determine panel optimum lag structure in this data? Simple thing is that as Andrew said that by differentiating more, you should not lose your variables. So as a result of that one, ultimately the sample size for your analysis should not be less down. Please explain the instrumental variable with an example. For example, I show you here is that, for example, so here, if you see this, the equation, if you see here equation, I have played with instrument variable here. Okay. See here, instrument, I have taken this the diversification, the growth rate of GDP, inflation rate, and interest rate. Okay. So somewhere I have taken the more instrument here, diversification, deposit growth rate of, again I have taken more. So I'm playing with this instrument because this instrument plays a very important role with your result of autocorrelation and the Hansen test and the Sargent test. Because if these instrument variables are not rightly defined, then automatically we have a problem. That's what, again, somebody has said that what lag you have taken. Here I have taken the lag 1-1. Means first differencing I have taken. So if I go for the more differencing, then there's a fear of losing it. But in the first differencing only, the problem of heterogeneity is taken care. Again, the individual error is taken care. So then I don't want to go for the further lag. So this lag 1-1 is only fine with a constant I have taken. So this is where you can see myself that in these models I have played with my instrumental variables. So because ultimately these instrument variables are very important for this in your panel data analysis. And
questions?
Okay.
Friends?
So, Shantanu sir, you have some question?
Yes.
Hello.
Shantanu sir.
Sir, can you please go to the do file, sir?
Do file. This only do file. You can see this do file, no?
No, sir, the do file is not the, sir, the
1 minute. Oh, 1 minute. Then you're not seeing the do file. You're not seeing this file? Command file?
Yes, a command file is there.
Oh, this is a do file editor.
I think he wants to see that the programs, what you shown.
Yes, sir.
You want to see the PRG file?
Which one, Bala?
The commands you show, no? Some commands.
Sir, yeah, from where you were copying the commands actually.
Asking to check with that note file from where you copied your command.
No, that's what I opened. No, you're not able to see this one.
No, it's only results are displayed here.
Only what is results are displaying. Okay, fine. Okay. That's what I was.
Output is
now. This is share. One minute. Now?
Yeah. Yes, now.
Sir, just 1 minute. I was thinking that I am able to show you this data. Okay, so somebody asked me that
yes,
somebody asked me that how do you play with the instrumental? Okay, For example, here, if you see these instrument variables, here you can see that these other variables, okay. So what I see, you can see this instruments are different for each model. Okay. So diversification, positive total assets. So here, if what I did is that each model I have taken added different model for this checking. I have taken loan loss reserve in here. So again, I have changed my inflation rate interest rate. So diversification, because I'm playing with my instrument, whatever the instruments are available, to check that ultimately I'll get the better result. Again, if I come to here, I have taken only three instruments: diversification, growth rate of GDP, and inflation rate and interest. So here it is, unless until these instruments are very important to show that how my results are changing. So I go on working on these instruments until I find that better efficient result in terms of your Sargent test, your Hansen test, and also MA1, MA0, and MA1. Okay, so Santanu sir.
Sir, I want to say that in the different options, what have been programmed in the do file, sir, can you appreciate the options in between the models you have considered, econometric specifications?
I couldn't
Like
get
how
it,
the
sir.
model is developed.
Okay, this specification.
Yes, sir. How the model is developing. Like the first one you pasted there and run the model. It was somehow there was some problem and you adjusted something, then again run the same problem. Sir, I want to specifically know what were those adjustments you did.
Okay, okay. So that is a big task, man. See, then I should go deeper into my equations. Okay. See, one is that if you see this first equation, I have taken no level, no difference sergeants, robust and small. What I did is that I removed this no difference sergeant. So these are the different techniques. Just if you type it in Google, you can have it. What I did is I remove the no difference in sergeant test. Then I run no level, robust and small. So like this, these are the four tests are there. No levels, no difference sergeant, robust and small. Okay, and again one more is that constant with no constant. The constant in the equation we take constant without a constant. So I have tried with the different one. Then I found then I have tried with in this different format to find which one is a better one. So this is a little bit.
Sir, I want to interrupt once.
Yes.
Sir, like the small, the base generalized, some commands are known to us who are basically working with it,
Working
like
on this
small,
one.
like small reports, the small statistics.
Yeah.
Robust means those are heteroscedasticity robust. There might be VC robust or whatever might be.
Yes, true, very true.
But there are some thing like no level or the main issues that you considered to get into the exact model. I wanted to know those specific commands so that we can, if we face problem in our analysis, we can adjust those or go for those adjustments.
Okay, okay, fine, fine. So I'll do one thing is that I'll send you one file where you can have the clear description on that one. Is it fine?
Yes, yes, sir. That will be surely fine.
Fine, fine. Thank you, thank you, thank you.
Yes, sir. Thank you.
Please, Balak, please take Shantanu Ghosh's email ID. I'll send him one file.
Yeah, okay, Suresh. Otherwise, you can share it to me. I can.
I'll share it to you. Okay, fine.
Otherwise, Mr. Shantanu, you can type your email ID also in the chat box. Dr. Suresh will directly.
Yeah, I'll copy from you directly. Shantanu, please type your email ID.
Sure, sure, sir. I'm typing.
Sir, one more doubt.
Yes, yes, please.
One thing you have shown in the output that the first difference method will give the best solution. So based on which parameter or coefficient we can decide that the first difference method is the optimum one?
No, first, Vamshi, the first thing is that why you are going for the dynamic panel data. Okay, that first you should understand is that because there is an endogeneity problem in that, because we are taking the lagged dependent variable. That is why it is your dependent variable. The lag dependent, the yi t minus 1 is your we have taken towards the right hand side, which we call as an independent variable. In the independent variable category, we have taken yi t minus 1. Again, we have what is that yi t is a dependent variable. The same variable we have taken the lagged y t minus 1. So when we take this both the variables, there is a fear in the equation that this yit minus will be serially correlated with your error terms. So in the error terms, we have the individual effect and the general effects are there. So what happens is that many a time these individual effects or other things will not be able to. Simple example I would like to give you is that, so there was a study by the Ireland on Bower only in the earlier days. So they want to study the consumption of cigarette region wise. How does it affect on the efficiency or something else? And they found that the regional data they have collected. There is one constituency, one region is there, they call as Utaha, which is a mostly Muslim populated. Okay, so when this Muslim populated region is less smoking people are there, because the religious aspect comes into the picture, where in the religious book they said that smoking is sin, the smoking is a sin in the book. So as a result of that as we know that Muslims community people, they do smoke less. So how this individual things you are going to assess? So for that, they use some dummy variable to do that one. They do that dummy variable, then overcome that kind of a problem. But the point is that when we have the lag one, that's what I'm telling you, is if the for example, if you use the co-integration analysis, other things is that we have lag 1, lag 2, lag 3, like this. You go on to assess that where actually your data is significant. So but here we are taking lag 1, because on the lag majority of the time, if you go on working on this data set, you find that in the lag 1 only your endogeneity problems will be taken care. So that's what I found from my work. So that's where you can also, when you work on these data files, then you will really understand that where we are actually facing a problem. Vamshi, is it fine?
Yes, sir.
Okay, thank you. Santamji or Ravinder, that's only now.
Dr. Suresh, somebody is asking basic steps to consider while running GMM.
Basic step 2?
Considered while running GMM.
You should take care of your Sargent test, Hansen test. That's where the most important thing you should consider while running GMM. And again, the instrumental variable which you take into the model, that you should be considering, because that's what I have tried taking the few instruments. I have tried different model. That's what we do, especially because what we do majority of time, even the simple panel data. For example, we take variables like x1, y1 is equal to x1, x2, x3, x4, x5. In that x1, x2, you find the more correlation. What we do is that either one of the variable will drop. Again, we run the model. And what is the basic idea is that to see that ultimately you find the efficiency in your model. So here also in the Sargent test, that's what I was showing in my result also. As if you go on into the literature, if you go on into the literature, you can see this, the Arnold bond test AR1, AR2, and the Sargent test, Hansen test. This 4 is very important in this GMM model. If this data is not efficient with the given condition, then whatever the model you have run, whatever the result you got is inefficient. So you should check with this Arnold bond and other things. So that's where it is important for us to come to the conclusion that whether we should go with the GMM or not. So shall we stop, Bala?
Yes, doctor. If any questions, otherwise better you can share me the file. I can share with those who is required.
Okay, fine. I'll share the file with you, and you can share the same thing with others also.
Any questions, friends? Because resource person have a few more minutes to share the section. Any questions? Friends, participants, ma'am.
Hello, sir.
Shantanu sir.
Sir, can you please suggest some literature that highlights the differences between using the GMM setup in two-stage least squares
Sir,
and
I'll
and
just send you the Baltagi book is there.
okay, sir.
That book, one chapter is enough to understand why we should go for the panel data.
Okay.
Okay, that one chapter is there. Again, there are certain literatures are also there where we can see that. It is comparison between the why can't you go for the panel data? Why you want to go for the GMM? Okay. Again, when you go for the panel data, it's then there's a next level is that if there is any endogeneity problem, first this Andrew Asio suggested go for the instrument variable to overcome the instrument, overcome the endogeneity problem. Okay, even what is happens in the Andrew Asio model is that when you go for the instrumental variable, the more differencing what happens is that you're going to lose more variables from your sample. So what happens? Your sample size goes on decreasing. But why GMM is that? That's what initially said is that in the GMM, we are not, even after differencing, we are not going to lose because of the instrument variables are there which can taken care. So as a result of that one, if you compare between the panel data is always the best model for us when we don't have the dynamicness in the model or we don't have endogeneity problem. But when there's when we take as a lag dependent variable to assess the endogeneity, then among the models which is available is that system GMM is a better one in terms of assessing your model. That's why there's a one book by Baltagi sir that is very good. It's a book on panel data. Then they talk about Arlina bond model, but it is around 30 pages or 40 pages. They will go on explaining why GMM is important. I'll send you that link. I'll send you the link of the book, or I'll send you that book to the Bala. I think you can refer to that one.
Sure, sir. Thank you.
Okay, Shantanu sir. Bala, Dr. Bala, I'll be sending you that book to you also. You can share with you.
Just a minute. Give me a minute. I'm gonna call. Okay. Just a minute.
Sir, a very basic question. I'm just new to the panel data. The GMM model is used only for the panel data, not for the time series, right, sir?
Time series also you can use.
Yeah.
But you should understand that what is T and what is N. How much T and how much N is there. There's one condition in the GMM model.
Okay.
Usually we are using GMM in time series also. Sometimes your 3SS and 2SLS, you can't apply a simple OLS. If that is the case, you have to think about GLSS. GMM is nothing but the other method of minimizing your errors and maximizing the output. Okay. So yeah, use depends upon the situation. Suppose you are talking about some kind of modeling kind of thing, and then some interactions between the variables where there is a possibility of simultaneity. So you're using GMM, where those things can be addressed easily.
Okay. Thank you, sir.
Yes.
Thank you so much.
Yes. Any more questions? Participants? Any questions, friends?
No, sir.
Yeah, actually, I just Dr. Suresh, just give me a minute. I just want to make a small announcement. Probably the third session may start a little late because the person who committed to deliver the lecture was not in the position to deliver. So we preponing the session, day after tomorrow sessions to today's evening. So maybe the session will start instead of 2:30, maybe it start around 3 o'clock. Okay.
Okay, sir.
All of you, please check there is another session, but it starts at 3. Okay, I will update in the group, so please check it. Don't. But the forum will be open. You can join at any time. But it seems that resource person will join only at 3 because he want to include few more things. So Dr. Dureraj is going to present the session today on quantitative response models. Somebody is asking about that, right? qualitative response models. We can discuss about logit orbit and other kind of models where we can deal with qualitative data. Okay, don't miss it. Just try to be on time. Kindly bear with us for this inconvenience. Right. So I will post the timing in the group. Be in touch. Right.
Yes, sir.
Any
Thank you,
questions?
sir.
Dr. Suresh, if you don't have anything to share, then we can wind up.
Yeah, fine.
Thank you. Oh, yes. So, Prakash.
Okay, sir. I would like to take this opportunity to thank our speaker, Dr. Suresh Nayak, for the enlightening presentation, which gave us valuable insights about the panel data. I'm sure this session has cleared up a lot of questions. Thank you, sir, giving us so many points to ponder upon. Thank you, sir.
Thank you. Thank you, Dr. Bala, for giving me this opportunity to give a small presentation.
Thank you, Suresh. Thanks. Thank you so much for your time and efforts. I'll be in touch. Okay. I'll call you back. Thank you, friends. We'll meet after lunch. Okay.
Thank you, sir.
എന്താണ് പാലയില് അമ്പാർന്നൊരു പേര് അറിയോ ഭരണങ്ങാനടുത്തോ
ഫോണിൽ സേവ് ചെയ്ത് Hello, Durai. Dr. Durai Raj?
Hi, Balaji. Am I audible?
Yeah. Yes, Balan. How are you?
Yeah, I'm fine.
Session will start in another 10 minutes.
Yes, okay.
Okay. I think we can start. Okay. Durai, am I audible? Dr. Durai?
Yes.
Yeah, I think we can start. Almost more than half of the population joined. So we can go ahead. Anvesha?
Yes, sir. Sir, am I audible?
Yes, loud and clear.
Okay. Good afternoon, everyone. Welcome to the 11th session of data analysis using econometric models hosted by the Department of Economics, Central University of Tamil Nadu with association with Atal Academy. This session shall be on quantitative responses model, which shall include logit, Tobit, and Probit models. I take this humble opportunity and it's my honor to welcome the speaker of today's session, Dr. Durai Raj Kumaraswamy, from Assistant Professor from Manav Rajana International Institute of Research and Studies. He has done his MS, MPhil, and PhD in economics. He has an experience of 10 years. His research interests are trade, foreign direct investment, regional integration, production network, financial development, and applied economics. Few of his journal publication details are promoting foreign direct investment in the Indo-Pacific region, scopes and opportunities. access to finance, financial development, and farm and exportability experience from Asia Pacific countries. Do electronic payment in banking affect inflation? Evidence from India. Foreign direct investment, export, and economic growth in India, and application of ARDL model. Long run casual nexus between foreign direct investment and foreign trade in India. He has attended many international conferences. Few of them are changing dynamics of India's trade in the COVID-19 era, held in 19 November 2020. Asian India trade and value chains in COVID era, 22nd May 2020. India-Vietnam maritime connectivity, trade and investment opportunities at the inaugural workshop of India-Vietnam Maritime Cooperation organized by a National Maritime Foundation, New Delhi, 23 April 2019. He attended national conferences as well. He has a huge contribution to books chapters as well. He has been affiliated to Life member the Indian Econometric Society, India and Forum for Empirical Research in the International Trade, member of American Economics Association, UAC, East Asia Econometric Association, Japan. His notable honors and awards are officially selected for Visiting Scholar 2021 Korea Institute of International Economic Policy, Seoul, South Korea 2021, award research grant from Institute of Development Studies, University of Sussex, United States, United Kingdom 2018, award research grant from the Asia Pacific Research and Training Network on Trade, UN SCAP, Bangkok 2015, TTI IEG and at assistant professor level fellowship Indian Institute of Economic Growth, Delhi 2013, and he was a gold medalist for MPhil degree Pondicherry University for the year 2005. So I open the platform to Dr. Kumaraswamy. So you are most welcome.
Thank you, Anvisha Goswami, for your generous introduction.
Your voice is very low.
Am I audible?
Yeah, but it's very low. You're audible.
Okay.
But
now it is audible?
Yeah, it's fine, but it seems
Okay.
that voice is very low. Can you
Okay,
slightly
okay.
increase it?
Thank you, Anvisha Goswami, for your generous introduction, and Dr. Balaji for inviting me to this faculty development program on data analysis using econometric model, and also given me a topic on qualitative response models. And I also thank Tamil Nadu Central University for their consideration for inviting me. So I will just quickly move on to sharing my presentation, and please let me know if any issue comes, then I'll. Can you all able to see my screen?
No, Durai, yeah, now it's okay.
Okay, okay. I'll make it full screen so that you can see it. Now, can you all see my full screen?
Yeah.
Okay. So, how am I planning to make this presentation today? This is topic is on quality response model. You usually we often gender male and female, how you quantifying it. So when you are quantifying the data, that data is actually qualitative in nature. When you are quantifying, you are decoding with some assigned values. Okay, so whether that variable that assigned values given in the independent variable or in the dependent variable, there are several challenges when you apply usual ordinary least square regression model. So I'll be briefly covering what if this qualitative variable that you include as a independent variable, how the model structures look like, And I'll be briefly covering because the title is qualitative response model. So I'll focus more on linear probability model, logic model, probability model, where you are assigning the qualitative variable as a dependent variable in nature rather than an independent variable in nature. So okay. So the regression model basically deals with the quantitative variable. Like mostly you can also explore the GDP data or the price data. Mostly it is in the secondary data where whatever we collect is mostly in the continuous series, where you have the data unique values for each particular cases. But most often the qualitative variable like nominal scale in nature, such as race, color, gender, etc. We are for example, if you are trying to assign certain values for the gender, for example, male, we are assigning 0 and 1 for male, and you are trying to apply that into the model as an independent variable in any of the model. We will see what are the examples that where we can apply it. And that qualitative variable that assumes 1 and 0 are called as a dummy variable because we are assigning the value for a qualitative data in nature. So since that is why it is called as a dummy variable to classify the data into a mutually exclusive categories. Okay. So now there is a illustration with certain examples I'm showing you for your understanding, where you can see there is a scatter plot between annual recurrent expenditure, that is the cost variable on the y-axis, and the x-axis it is a number of students enrolled for the particular group of courses. What are the group of courses? One is the vocational school, the another is a regular school. So vocational means training is a technical education where they have to engage in laboratory works, and that cost of establishing that type of school may require huge cost compared to the normal schools if a lot of machineries are required for experimentation and so on. So now we are trying to see whether there is any cost differences between the vocational and regular. When you are not actually assigning any value as such, but this is a simple scatter plot that I'm showing here. The red dots showing the vocational, and the black dot showing the regular. Assume now the data are as such, and you don't have any other variables that are influencing, but now you're trying to find the differences of cost factor between the vocational schooling and the regular schooling, and how that is influencing in your model. So if you want to find only the cost for the regular courses, then you may know that what are the regular courses that you have, and for that you can run a simple regression. For example, cost is a function of beta 1 plus beta 2 n plus the random error term. Similarly, in the vocational courses, again, similarly, the same regression you can also run. Cost is equal to beta 1 dash plus beta 2 n plus u. So now what you will be getting from these two models, if you run a regular course, the regression model, you will be getting the cost factor associated with the impact, the cost associated with the regular courses, versus the vocational course, you will be getting the cost factor associated with vocational courses alone. Now, when you look into the graph, since the regular courses, the cost is relatively lesser than the vocational courses, here you can see the intercept term beta, it's a little lower compared to the vocational courses intercept beta 1 dash. So when you are trying to run a regression model only for regular courses, you will be getting a linear line. Now we are assuming the marginal effect for both vocational courses and regional courses, regular courses are the same. That means there is no changes in the slope, but only changes in the intercept. So the differences that you're trying to identify, assigning the value for vocational or regular. For example, you are assigning a value for regular as 0 and assigning a value for vocational as 1. So that is what written as a course is equal to 0 for regular and 1 for vocational. So now when you are trying to run
Dr.
a combined.
Durai, just a minute, Durai.
Yes.
There is a small
Yeah.
gray box is shown in between the presentation.
What it is showing?
There is a gray box. There is a small gray color box is shown. Yes, your mouse is there. No, when you touch the mouse, it shows a gray box.
Okay, okay. So I'm trying to show using my mouse the particular places.
But it's,
so it is my mouse icon is not showing now.
Yeah, it's hiding everything. Yeah, now it's fine, but there is a box. The last 2 lines of your presentation was blocked actually. Yeah, now it's keep on moving.
Okay, okay.
Whenever you move the mouse, that will covered by a gray box. It will
Okay,
hide the
okay,
text
okay.
actually.
Just a minute.
I think your pen tab was switched on. Maybe that is the reason why it shows some gray.
So now it is okay. I'm actually disabled my video because I just want
Fine.
to show
Now
my
it's fine.
PPT.
Not showing. You can carry on, doctor.
Okay, okay, okay. So what you see here, instead of running as individual 2 different models, one for the regular course and one for the vocational course, and now when you try to run a regular model, you don't actually see the differences between 2 different courses when you are trying to estimate the cost factor. However, if you try to combine the model, so how we are combining? So the general beta 1 is the intercept term plus delta course. So now you are assigning a dummy variable for 2 different courses, one for regular and one for vocational. So you are assigning a value 0 for regular and 1 for vocational. Now we are including that as an independent variable in your model, delta course plus beta 2 n plus u. So now this course, delta course, will actually shows the difference between the cost differences between the vocational and the regular one. Okay, so now here what we are showing, the beta 1 shows here a regular course 0, which is a reference or a base category. Why it is a reference or a base category? Because here again, as a researcher, you can call vocational as a 0 or regular as a 1. It's up to you which variable that you wanted to focus. That prime variable, particular course, you can call it as a 1, and the other courses you can call it as 0. So whatever the value that your courses that you are assigning as 1, that will be considered as delta course. That will be the coefficient of your coming year. The one which you are assigning as 0 will be the reference or a base category. Okay. So because you are not assigning any particular value for the regular, it is 0. So now it is a reference or a base category that is called. And the delta shows here is a vocational course, which is beta 1 plus delta. If you see here, the beta 1 dash is nothing but beta 1 plus delta. Okay, so the delta is a coefficient which actually shows the beta 1 plus how much increment in the differences because of the vocational courses in the cost factor. So beta 1 plus delta is nothing but your delta courses. So assuming the marginal slope is effect is constant in both vocational and regular, we are actually now concerned only about the intercept term between beta 1 and beta 1 dash. Now this intercept, the interpretation of this particular model will not tell you the reasons behind the differences. It will just simply show the differences in the interpretation between the vocational courses and the regular courses. So that also you have to keep in mind that when you are interpreting. So how we are actually structuring that data in the for example, assume now we have a list of a school, number of schools you have, and this is the type that we were discussing about, vocational and regular courses. Okay, and this is a cost involved for each particular courses that particular school is offering, and the number of students enrolled. And this group is nothing but we are calling vocational as 1 and regular as 0. So our target prime variable focus is on vocational. We are calling that as a 1 and 0. So when you are assigning a dummy variable model, you should assign like this only 1 0 1 0 or 1 0 like that, rather than assigning a value something like vocational and regular. So now when you see it, this itself capturing the differences of vocational and regular with this dummy variable. So instead of including like this as a group, suppose you are including vocational and regular. Wherever vocational is coming, you are assigning 1, and wherever regular is coming, you are assigning 0. Similarly, when you want to emphasize on regular, you are assigning value 1 and the rest vocational as 0. Suppose you are including these two dummy variables into the model, vocational and regular, and in addition to that intercept term, then you will end up experiencing the dummy variable trap. Okay, so that also you have to be very careful when you are including the dummy variable, because the one which is called as a base one that I shown here, base category or a reference category, which is nothing but the intercept without having this one, that assigned value here. Okay, so when you are not including, when you are not including specifically the regular, but including only this dummy variable which has a 1, then the intercept itself capturing the effect of the regular courses differences. So that is how we have to keep in mind. So suppose if a qualitative variable has M categories, similar type here we have used only 2, vocational and regular. Suppose you have more than 2 different 2 category, vocational, regular, and maybe we can call as technological. If there are 3 categories, then M minus 1, 3 minus 1, dummy variable only should be used in the model. In our case, it is only 2 minus 1. So we have to use only 1 dummy variable in the independent model. In addition to the any quantitative or qualitative dependent variable that you are including in the model. Okay. So either you can use cost is a function of beta 1 plus delta course plus the independent variable plus u. Here, this course is nothing but the group that we have a dummy variable, or you don't need to include your intercept. Rather, you can include delta 1 vocational and delta 2 regular. Since you are not including intercept variable in the model, so these two models are also valid. No problem. We can include like this. But if you are including a model like this, cost is a function of beta 1 plus delta 1 vocational plus delta 2 regular, then you end up experiencing a perfect collinearity between vocational regular, which is nothing but reflected in the intercept. So when you are dealing with dummy variable in the independent variable, you have to keep in mind that you should never use all categorical variable in the model. Rather, you can use M minus 1 dummy variable in the model. So what we have seen so far is only for the slope intercept. So you can also try to find the changes in the intercept differences only. But if you can also similarly find the changes in the slope as well by multiplying your dummy variable with the slope to see whether there is any changes in the slope as well. And this is widely used for the Chow test, where they try to see the structural changes in the model or not. Okay, so there are a lot of advantages, but at the same time, there is also, we have to keep in mind the dummy variable trap that should not affect your overall model. Okay, so so that is the basic background for the dummy variable model if you include that in the independent variable. Since my focus is more on qualitative response models, I'm not going in detail the explanation on dummy variable. We'll move on to qualitative response model. So what is qualitative response model? Usually in the general OLS model, your YI is usually a quantitative variable. So and xi can be quantitative or qualitative variable. So here the qualitative variable can be a dummy variable that you can include, and xi can be a quantitative variable, anything that changes, a continuous series that you can include in the model. But what if that if your dependent variable is qualitative in nature, that is a dummy variable. For example, it can be a nominal data. There is no inherent ordering like religion, race. There is no any proper order, but you want to trying to find the effect of that on your religion or race. And maybe it may be ordinal data where ordered categories are given. Age group 0 to 18 or 18 above, and less than 18 between and 18 and above, or a class group, anything that is based on the ordinal, or a count data, which is a rare event, for example, number of accidents in an hour. So that type of dummy variable you are experiencing as a dependent variable, which is qualitative data in nature, then it is called as a dummy dependent variable model or a binary response model. There are several contexts where we are also want to be more curious uh, to raise certain questions which are often in the qualitative response model basis. For example, why do some people go to college while others not? This is a very usual questions at times we may tend to ask, where how you are actually assigning the dependent variable, one people going to college and zero if not. So you are trying to find the factors that are determining the people who are going to college versus the people who are not going to college. There could be n number of reasons that we can think of. For example, maybe their standard of living, their income of their family, and maybe the long distance, or the particular individual maybe staying in rural areas. Maybe there is no transportation availability, or his interests also may be different. So we do not know what reason. So why do some people go to college while others do not? So here in this case, your dependent variable is a qualitative response variable, which is having a value 1 where people going to college and 0 if people not going to college. Similarly, why do some women enter the labor force while others do not? This is also another interesting questions where why uh, some certain group of women are going for entering into the labor force while some women are not entering into the labor force. Either maybe there depends on the education, they may not be educated well, or they may not be going, or they got married, and because of married maybe having 2 3 more children, so they are more committed, or they may not be having a experience, so that they may not be able to go, or their husband wage is more sufficient enough, so they are not allowing, or the husband or father's income is sufficient enough, they may not be allowing the women as well. So there could be any reasons that you wanted to find out. And similarly, why do some people buy houses while others rent? So here one people have houses and 0 if rented. Similarly, why do some people migrate while others put? So like this, there are several hypothetical questions that you can raise, and you can start collect the data from the by yourself, or maybe a lot of several survey data are also available, where from there you can raise certain questions and you can try to run this type of qualitative response models. And the last hypothetical question is, what are the factors that are determining firms' decisions entering into export market? So here we can assign 1 where the firm's decision to export, and 0 if not. So this is again interesting question, because there are several other factor which are determining firms first engaging into the both domestic market and foreign market. But to enter into the foreign market, it is very competitive in nature, where firms has to be well equipped in terms of upgrading their technology or updating their machinery, and they should also have a sufficient um, um, investment should be there. Either they can, if not available, then they should have a easy access to finance from the bank or non-banking financial corporations. And the size of the firms also very much important. If it is a small scale enterprises, then they may not be that much competitive like a large enterprises scales. So there may be n number of reasons. If their plant is very closer to the port, then it is easy access to them. The transportation cost is little bit less compared to the firm which are located somewhere in a remote place, where the transportation cost is very huge for them to export to any other market. So because in a competitive market, even a small unit change in price also is a very big concern. So the infrastructure development is also very much important. The infrastructure development in terms of road, port connectivity, and so on. So there are several factors which are actually influencing the firms to determine whether the firm to export or not to export. And both the institutional factor and non-institutional factors are also plays an important role in terms of deciding it. So this type of policy, there are often most of the questions are also policy relevant questions, which even the government also wanted to know, and accordingly they can actually formulate the policies. If, for example, if the firms who are in rural versus the firms who are in semi-urban or urban places, how their decision towards taking a decision to export. If because the firm is in very rural area, they may not be much assessed to the finance or assessed to the port connectivity and so on. Then they may not be much motivated because of that compared to the firms who are in the urban areas. So then accordingly, the firms, the government have to take a decision, take a policy measures in such a way that they can try to provide access to finance, even though the firms are in rural areas, and trying to strengthen the connectivity in such a way that even the firms who are in remote place can able to take a decision to export to the foreign market. So there are certain questions we have to apply the qualitative response model in such a way that also help you to take some policy relevance decisions. So so the basic model that we apply using the OLS framework. Why do some individuals own their car while others prefer public transport, for example? Here, we simply apply the OLS based model where y is equal to yi is equal to 1 if having a car, if yi is equal to 0 if not having a car otherwise. Now, this is a typical different variable which is a qualitative nature. You are applying using the basic linear probability basic OLS framework. Okay, so now here you are assigning y is equal to 1. This means the probability of the particular individual owning a car, and yi is equal to 0 is the probability of that particular individual not owning a car. So here the P of yi is equal to 1 is the we have pi, and if it is 0, then we can call it as a 1 minus pi. Okay, so in this case, expected yi given xi. So given xi, that xi may be income. So that depends on the income. The individual is deciding whether to own a car or can access the public transport. So your yi 1 or 0, it depends on the given the level of income. So expected yi by xi given xi equal to alpha I plus beta I. So this we can write it as expected yi is equal to 1 into pi plus 0 into, so either there are two options. One, the individual is owning a car or the individual is not owning a car. Okay, so this is the only two options where the individual is having, and we also know based on the available data how many number of individual decided to own a car, having a car, and how many individual did not have a car. Okay, that we are assigning a value 1 and 0 already. So the expected yi given xi is equal to the probability of I, which is alpha I plus beta xi. So this is a very simple, straightforward OLS framework model, which is actually called as a linear probability model. So we are actually now trying to see the probability of individual owning a car or not, applying in the OLS framework. So since we are applying this linear OLS framework, then the conditional mean of yi indicates the probability of owning a car, which is a linear in nature. So the probability here is a linear in xi. So any changes, for example, now assume that an individual who is earning 50,000 a month, and another individual who is earning 1 lakh a month. So now in between 50,000 to 60,000, whatever the difference is, the probability is same as between 50,000 to 1 lakh. But in reality, it is not, right? So the moment if any individual's income shifted from 50,000 to 1 lakh is is having more probability or likelihood to own a car compared to 50,000 to 60,000, because the difference between 50,000 to 60,000 is only marginal 10,000, whereas 50,000 to 1 lakh is marginal 50,000, right? So now assuming a linear probability, the probability is linear uh, throughout the data point given xi is actually not possible. But that is the assumption because it is based on the OLS framework. It is assuming that the probability is linear in xi. So this is one of the shortcoming of this linear probability model. Okay, because the 50,000 to 60,000 is very marginal increases compared to 50,000 to 1 lakh. But so we cannot assume that the slope is constant throughout this data point. So it is in reality, this is not the case where you can have an assumption of having a linear marginal effect given the changes in the xi. Okay, and here the probability since we are or dependent variable yi is between 1 and 0, your probability always lie between the 1 and 0. Okay, it should be greater than equal to 0, lesser than equal to 1. Since Priya is between this range, your expected yi given xi also within the range of 0 and 1. And since your expected yi given xi is nothing but your alpha plus beta xi, as we have seen here in this equation, that is also should lie between the greater than 0 and less than 1. But in reality, there is no any guarantee that your pi lie between 0 and 1. It may exceed beyond 1, or it may exceed less than 0 as well. My negative value also you may come, because you are applying a linear probability model where it's a very straight line and it go beyond 1, or it even go less than 0 as well. Okay, so that guarantee we cannot give when you are following when the probability is linear in nature. So in this context, can we estimate the linear probability model using the OLS? Certainly not. There is also another problem that you will be facing, because given that your yi is discrete, that is not continuous, it is assigning value 1 or a 0. So the probability of owning a car or not owning a car is certainly in the limit of 1 or a 0. So it is not a continuous data, right? But the distribution of UI is not actually discrete. It is actually continuous. It's actually having a normal distribution property. So given that case, since your yi is choosing between 1 and 0, your yi is nothing but 1 minus alpha I minus beta I xi, whereas your yi is between minus alpha I minus beta xi. So your error is actually between 1 minus alpha I minus beta xi or minus alpha I minus beta I xi. So it is actually lying either this range or this range, given your y is equal to 1 or y is equal to 0. Therefore, the distribution of yi will be discrete, that lie between 1 and 0, and instead of continuous normal distribution. So because of this reason, you cannot apply the linear probability model, but the basic concept, what we are trying to explain, that the model can be applied, but there is a certain limitation. One limitation, the conditional mean of y indicates the probability of owning a car is not actually linear throughout your given xi. So it depends on the changes in xi that your probability will be changing it. Secondly, your distribution of ui is a normal distribution because it is continuous. So given that your yi is discrete between 1 and 0, your ui also will be discrete. So it is actually also not fulfilling the assumption of your OLS model as well. So because of these two reasons, basically, you cannot run the linear probability model. And that is where the logic model is coming in. Okay, so in the logic model, what is actually happening, assuming that your probability is your f of z, which is keeping that 1 by 1 plus e to the power minus z. So your z is nothing but your alpha I plus beta xi. Now assume that this is a model framework that they're giving for your probability. Okay. Now this is basically a non-linear framework, right? So because your probability is nothing but 1 by 1 plus e to the power minus z. So now given it is a nonlinear, we can actually transform the nonlinear model into a linear model. So how can we do that? We can convert that into a pi by 1 minus pi is equal to e to the power zi. So when you're trying to do that derivation, you can get pi by 1 minus pi. Okay. So then you take log both the side. You will get log of pi by 1 minus pi is equal to e to the power zi. When you take log, it will be zi, which is nothing but your alpha I plus beta xi plus your the unabsorbed term, the error term. Okay. So now what is this pi by 1 minus pi? So this pi by 1 minus pi is a dependent variable which is given in the odds ratio. Okay. The odds ratio where the probability of occurrence versus the probability of not occurrence. So this is a ratio between the probability of occurrence of the event divided by the probability of not occurring the event, where your yi is actually given as 1 and 0, where 1 means your probability of occurring the event, which is pi, and 0, which is not actually occurring. So it means the probability of the individual owning the car versus the probability of individual not owning the car. This graph I will explain you. I just wanted to show you what differences that we are seeing compared to the linear probability model, where we have a single straight line, the logic model, where it's like a sigmoid S-shaped curve. I will come to that in the later classes. So now here, suppose you apply 1 and 0 in this typical log of pi by 1 minus pi odds ratio. Assume now your yi is equal to 1. So when you replace that pi as 1, 1 by 1 minus 1, which is nothing but log of infinite. Okay. And now you replace your pi as 0, then it will be 0 by 1 minus 0, which is nothing but log of 0. So now actually it is shows that the range is actually between the log of 0 versus the log of, if you keep your yi is equal to 0, then it will be log of 0. If you keep yi is equal to 1, it will be log of infinite. Then you have to actually understand and the relation to own a car. When he is owning a car, you are putting 1. If you are not owning a car, you are putting it 0. Okay. And this is actually based on the given level of income that he has actually ever taken a decision. But what is the probability that whether the income increases, whether you will be owning a car or not owning a car is not actually very clear, right? So you have observed variable based on the decision that the individual has taken, that is 1 and 0. But what is the realized value based on the observation, given that probability change in if the income increases, whether you will be owning a car or not owning a car, actually it is not given here, right? So your yi is the realization where the typical value of yes or no is defined. Here the pi is the probability that lie between 1 and 0. Okay. If any small changes in the marginal effect of the income from 50,000 to 60,000 or 50,000 to 80,000, whether will be likely to owning a car or not owning a car, that is not very certain. So that is the probability that actually lie between 1 and 0. Okay. So here your pi is not equivalent to yi. Because of that, your yi is a realization. You have decided the individual has decided to own a car or not own a car. So that is 1 and 0 is given. But that is not actually equivalent to the probability that lie between 1 and 0. Because if any changes in the income, the decision of the individual might be changing. So that always range between 1 and 0, right? So that is, you should not confuse with your pi is equivalent to the yi here. So your pi is not equivalent to yi. Your pi is a probability which lie between the 1 and 0. Okay. So here we cannot use the OLS to estimate the logic model, because the typical the distribution properties of the logic model is actually little different. So that is where we have to look into the maximum likelihood estimation. So to estimate the logic model, we have to know what is meant by maximum likelihood function, estimation function, and to know that we have to first understand what is this likelihood function means. So this likelihood function is either it is usually based on the probability distribution function. It could be a binomial distribution function or Poisson distribution function, or it could be of any probability density or a distribution functions. Now assume now we have a probability distribution function where P and N are given. So P is a probability of occurring the event where N is the number of sample. For example, now you are tossing a coin 15 times. Okay, so your N is 15 times, that is known. And what is the probability of getting 5 yet? So now you do not know the outcome, but you can able to calculate the probability here, right? So because your N is given and you wanted to see the probability of getting your 5 head. So if you get a head, it is success. So what is the probability of getting your head? So here in this case, the probability distribution function is probability of observed event and given the theta, that is the set of parameters. Okay, so the set of parameters are here the observed event is the number of event finding an sorry. So here the observed event versus the theta. Theta is a set of known parameters. So the set of known parameters is actually known here because here based on the 15 times you're causing a toying, you can able to find the probability. Okay.
Excuse me,
So
excuse me,
the
Doc.
theta is known.
Excuse me, Durai. Durai, I think the gray box is coming again.
But I cannot see. I'm seeing only.
While you are moving your mouse, I think that will be covered. Actually.
Even I'm not moving the
If you
mouse
want,
as
I can take a snapshot. Okay. If
Yeah,
you
okay.
want, I can take a snapshot and share it.
But I'm not even moving the mouse section.
Okay, then you carry on.
Some technical error. Okay. So here,
yes.
based on the binomial distribution function, your probability distribution function is your observed event and set of known parameters. So here the observed event is the 5 head. Whether the head is coming or not, you do not know. But you know the parameter that what is the likely probability that you will be getting the head or tail, right? So your parameter is known here, but your observed event is unknown in the case of a probability distribution function based on your binomial distribution function. Okay. Now come back to the likelihood function, which is we are trying to look into the reverse problem of the probability distribution function. Now you have the data. The data is whether the individual is owning a car or not, given the income. Okay. Now you already know from the data that how many number of individual is owning a car, how many number of individual is not owning a car. Okay. That means your observed event is already known to you. How many number of individual is owning a car, how many number of individual not owning a car, right? And your sample size is also known. For example, you have 200 sample size. Out of 200 people, you want to find the probability of individual own a car, not owning a car, given the income. Okay. In this case, your sample size is known. Your outcome is also known. That is, the people own a car or not own a car. But the only thing you do not know is the parameter. That is the probability. The probability of own a car given the income. Okay. So if you look into this one, here the P of observed event and the which is a known which is unknown, and the theta is known, that a parameter is known to you. But on the other hand, in the likelihood function, your parameter is unknown, but what is known to you is the number of sample, that is the sample size, and the outcome of people own a car. So in your logic regression model, yi is equal to alpha plus beta xi. Your xi is given, your yi is also known, the number of sample size is also known. Now you are going to find the probability of own a car given the income. So what if there is any changes in income, whether will you be owning a car or not owning a car? That is what you want to find. So because of this, you do not know the parameter theta. Okay. So therefore, the likelihood function is a reverse of the probability distribution function, where here your likelihood function, you are trying to find the set of parameter, that is alpha and beta. So because your alpha and beta is not known here, you are trying to find the set of parameter that define the probability distribution function, so that you can observe the sample with the maximum probability. So what is the parameter that you can fix for alpha and beta in such a way that will likely to get a maximum outcome? So that you are actually trying to capture the alpha and beta through this likelihood function. So since you are maximizing the probability, your maximum likelihood estimate, that's why it is called as a maximum likelihood estimation function. Okay. So here, unlike OLS, in the linear probability model, your objective is to minimize the error term, isn't it? You always wanted to minimize the error term. Whereas in the case of maximum likelihood estimation, you are maximizing the likelihood of the occurrence of the event. Okay. So that is a major differences between the OLS based framework model and the maximum likelihood estimation framework model. So since you cannot apply your OLS frame model in the logic model, you are applying the maximum likelihood estimation, and where you are trying to find the likelihood of the occurrence of the event by trying to find the set of parameter which will help you to observe the sample with a maximum probability. Okay. Now, how do we estimate this logic model? Suppose you are L is equal to the probability of occurrence of individual y1, y2, y3, y4, y1. So this is the individual sample. Okay, the sample one, the probability of y1, the probability of y2. So you just multiply it. And here the n is nothing but n1 plus n2. That means you are arranging a data in such a way that the first set of individuals are owning a car. The second set of individuals are not owning a car. So I call this first set as N1 and the second set as N2. So N1 and not N2 who are not owning a car. So here your probability of Y1 multiplication of probability of Y2 till probability of Yn is having the set of owning a car plus not owning a car. Okay. So now you are arranging the sample with N1 followed by a N2. How you arrange? So P1, P2 till P1. So you are trying to arrange the probability of N1 people who are owning a car plus 1 minus P of N1 plus 1, because here your Y1 is people who are owning a car, you are assigning value 1, which is Pi, and people who are not owning a car, we are calling 1 minus Pi, right? So instead of 1 minus Pi, where this is 1 minus P N1 plus 1. So the next individual who are not owning a car. Okay. So till 1 minus Pn. When you're trying to write in a summing of the set of two set of individual who are owning a car and not owning a car, it will be I is equal to 1 to n1 of probability of I into the probability of not owning a car 1 minus pi. Okay, so this also we can write in this form where your yi is equal to 1 for first n set of n1 observation and y is equal to 0 for next n set of n2 observation. Okay, now you take log both the side, where you take log of L is equal to summation of I is equal to 1 n1 yi log of pi plus summation of y is equal to 1 n, sorry, this is n2 1 minus yi log of 1 minus pi. Okay, now your pi is nothing but 1 by 1 plus e to the power minus zi. So that is what we have seen in the initial stage. So this is the probability pi we have here 1 plus 1 1 by 1 plus e to the power minus zi, where z is equal to alpha I plus beta I xi, right? So now you substitute this pi in place of pi this value. So this is what the transformation, the nonlinear assumptions we are keeping to find the probability value for that. Okay. So what you are trying to find using this particular set of equation, here you are maximizing the set of parameter. What are the parameter? Alpha and beta are the parameter that you are calling it as alpha star and beta star, that actually maximize the the sample observation of the parameter, maximizing the probability of the occurrence of the event. Okay, so you are trying to find the alpha star and beta star that you are using for inference making. Okay, so this I already repeated, where you are in a OLS. In the case of OLS, you are minimizing your error term, that is summation of ui square. In the case of maximum estimation estimation equation, you are maximizing the log L with respect to alpha star and the beta star. So one advantage of your maximum likelihood estimation is that your your estimation is asymptotically efficient and approach normality asymptotically. That means you will get an efficient model and assume normality, but it happens only in a large sample. For example, you have a 30 number of sample or 50 sample, your logic model will not work effectively. At least you should have 250 and above to start with. A normal distribution that you will be having. So it means the logic model approach normality in a large sample only. Okay. In the conventional OLS model, you will be having a t-test, that is a small sample test where you will be seeing it. Here you will have to deal with the z-test. So in the to find the significance of that particular coefficient. I will also show you using my data with some example exercise where you can show all those differences. So this is the general differences between the linear probability model and the logic model. In the case of linear probability model, you're trying to capture the marginal effect directly. So your beta I is the marginal effect you are trying to capture just by applying expected yi given xi. Your pi is nothing but 1 and 0. Owning a car or not owning a car is a function of alpha I plus beta I xi. Okay. So when you plot it, typically your dependent variable either in the 1 or in the 0. So something like this only would be seen, right? And you're trying to fit a linear line. So this is actually not making much sense at all, right? So when your dependent variable is either 1 or 0, so it is actually lying either between 1 and the 0 itself. But when you have in the case of logic model where you are calling your PAI is equal to 1 by 1 plus e to the power I z, which is a sigmoid S-shaped function of z, where your f of z is a function of the explanatory variable here. So because of having the S-shaped function, okay, now here because of this functional distribution, we have already seen that if you assign the value 1, you will get a positive infinity or a negative. So this x-axis showing your z, which is nothing but alpha I plus beta I xi. So it is range between minus infinity to plus infinity, for which the probability will lie between 0 and 1. Okay. So the distribution of the maximum occurrence of the event, as long as if it is coming in this way, it is changing. You see, unlike here, it is marginal effect is the same, but here the increases in the given x, there is a changes in the probability of the occurrence of the event. So the probability of occurrence of the event is changing between 0 and 1. But here the probability of occurrence is between 0 and 1 is not actually changing because given the linear line, right? So here, given the changes in the income, even the marginal changes in income, it will increase the probability maybe from 0.50 to 0.51 somewhere at this point. But here it is either 1 or 0, right? So here the probability is actually changing, and the tail in both minus infinity towards or the plus infinity towards is actually remaining constant. So in reality, the probability does not change linearly. Okay. So given change in xi, but in lower and upper end may be constant. So here we are assuming a linearity, but we are assuming it is not linear. That is what we can actually see here. Okay. So this is a probability model. So this is a probit model. So probit model, what we are keeping here in case of y, we are calling it as a y star. So what is y star? Which is a latent variable, which is unobserved. Okay. So for example, you are calling the occurrence of the event That is, whether he is owning a car or is not owning a car, given the level of income, the changes in the income. Okay. But are you capturing the utility of changes in the income and how much changes in income that in turn having the likelihood of that particular individual owning a car or not? So here, given that your YI is just a decision which is not directly reflecting the utility of the individual that will be owning a car, even then the income increases from 50,000 to 60,000 or 50,000 to 80,000. We are calling that as a latent variable yi star. Okay, so your yi equal to 1 when your yi star is greater than 0. Okay, that means your probability is greater than 0. So here your pi p of yi is equal to 1 is equal to p the probability of yi is greater than equal to 0. That means only when your utility is greater, when you have higher utility, then only you will be going for buying a car, right? And that utility you are not able to measure. So that's why it's greater than 0. Okay. So if he is not buying a car, maybe his utility is very less. Maybe you don't have much sufficient income so to go for a income. So in this case, your yi star, which is less than 0 or otherwise. Okay. So now you are feeding that latent variable in the probability function. So that is equal to P of ui, which is greater than minus alpha I plus beta xi. So this is nothing but when you are keeping this on the other side and keeping ui, you are trying to find the difference of it. Since the individual will go for owning a car when its utility is greater, right? So here the utility is greater than 0. So you can write that as in the other way around as 1 minus function of minus alpha I plus beta xi. So here the f of alpha I plus beta xi is nothing but your cumulative distribution function. This cumulative distribution function can be of a linear probability model or can be of a logic cumulative distribution function of your logic model, or it can be of a probability model in the context of a normal distribution. That means in this framework, it depends upon your the cumulative distribution function of that particular alpha plus beta I xi that your the set of parameter that will be changing it. Okay, so that we will show. So this is where the difference of when to choose your logic model or when to choose your probit model, or the choice between logic and probit model, that will vary. Okay, so that we will see it in the coming slides. So here this f of alpha I plus beta xi is nothing but your cumulative distribution function, which can be of your linear probability model or your cumulative distribution function of your logic model, which is already know that 1 by 1 plus e to the power minus zi, or it is based on your normal distribution where integration of minus infinity to alpha I plus beta xi f of z dx, where your f of x z is equal to 1 by square root of 2 pi sigma square into e to the power minus z1 square by 2, where z is nothing but your normal distribution. Okay, so this could be of both. So now what I am doing, this is we already know log of 1 L is equal to summation of I is equal to 1 n1 yi log of pi. So this pi, in the place of pi, you are applying this f of alpha I plus beta xi. So if it is a logic model, you will be getting the same result. If it is not a logic model, if it is a probit model following a normal distribution, your coefficients will be a little different based on that. So you are applying the same framework where your logic model your probability function is different, and in the case of normal distribution context, your probability function is a little different here. Okay, so here again you are finding the set of parameter alpha star and the beta star which maximize the observed sample, and through this also you can able to find the inference making. Okay, now can you all see my screen?
Sir, we can see only half of your screen. There is a
Yeah.
gray
Now
shade.
I want to show my data actually. So I want to stop sharing my screen and start the screen again. I hope now you can see my whole screen.
Yes, yes.
Yeah. So I just want to show you briefly the difference between the linear probability model, logic model, and probability model, running certain some examples. Okay. So this is the data that I'll be using, which you can actually, the data is about married woman labor participation data set. This is required by the Reach for the introductory econometric. So you can download, I share from this particular website data set. So that will be only I'm using here. Okay. So here, what is this model? Let us see what are the variables are given here, and we can see it. So if you try to describe, we can find this INLF. So since the data is about married woman labor force participation, this data is about only labor force participation of the woman, married woman only. Okay. Here, 1 is assigned if the married woman is in the labor force, 0 if the married woman is not in the labor force. Okay. And these are the factors that are determining the married woman force are not. Okay. So the hours of work and the kids. Sometimes the kids who are having less than 6 years, they have to dedicate a lot of time for them to take care. If the kids is more than 6 to 18, then they don't need to give much of the time, so they can easily enter into the labor force. And similarly, women's age in years. So if the higher the age in years and suddenly they wanted to go back to labor force, they may not be motivated, or maybe because they don't have much of experience because they are working, they were as a household, they may not able to enter into the labor force very easily. So the lower the woman's age, there is high likely that they can enter into the labor force. If they are not, if they are continuously working, even the higher age group, woman group also can enter into the workforce with a level of experience. So that is where the experience also matters. So experience of the that married woman having in the labor force, and the years of schooling. So higher the education. So if they are very skilled, whether they are in the labor force or not in the labor force, because of their skill, they can able to get the enter into the labor force easily. So like this, there are several variables which are determining whether the married woman is entering into the labor force or not. At times, this is what I was referring to, the husband's hourly wage. So the husband's hourly wage is higher, then it may not be an incentive for the married woman to go for because that particular income is sufficient enough to run their household, right? If the husband's hourly wage is very less, then women are forced to go, or they have to go to the labor force so that to manage their daily household expenses. So like this, there are several variables are given here. Let us take a few variables, for example, and to run whether what are the factors that are determining the married woman entering to the labor force. Okay. So what we'll be doing, we are simply running a regression. This is a simple OLS regression model where you are running a regression model with married woman enter into the labor force or not. So here, this is nothing but 1 if the married woman enter into labor force, 0 if not. It's a function of, let us take this variable, kids. The kids who are having less than 6 years. So if the kids who are having less than 6 years need more attention, so that may not motivate the woman to enter into labor force because they have to be at home to take care of their kids. Then this one, and again, maybe I can take education, the other variable, experience, I take experience. The husband wage. Okay. So now This is a model that we see. This is a typical OLS framework model, linear probability model. If you are including a qualitative variable as a different variable, then it is called a linear probability model, okay, LPM model in the OLS framework. So when you run this model, you get a typical all the necessary diagnostic, which is specifically for the OLS model, okay. And this is the coefficients. Here we are actually directly capturing the marginal effect since you are running a OLS framework model. So what is actually suggesting here is that every one unit increase in the kid's age, there is a probability that that married woman going into the labor force will be decreased by 0.169. Okay, so if there is 1 unit change in the kid's age, there is a less probability that the married woman will enter into the labor force participation. So the number of kids that are having less than 6 age, then it is not incentivizing for the married woman to go for a labor force. Similarly, in the case of education, so 1 unit increase in the education leads to 0.04 probability to enter married woman enter into the labor force. So here we can actually try to understand the directional effect of this particular variable on the probability of whether the married woman is entering to the labor force or not. Okay, so similarly for experience and the husband age. So here you can see the husband age. Higher the husband age, lesser will be the probability that married woman enter into the labor force as well. But the problem, as we already discussed, here the probability is linear. Secondly, your the disturbance term or the error term is discrete. Because of these two factors, you cannot typically apply this linear probability model. Okay. There is also another problem, which is the case of a R square. Okay. So let us see that. So here what I'm typically running, this is the model I ran. Married woman labor force participation function of the kids who are below age of 6, education, husband wage, and the experience. Okay. Okay. So this is a typical model that we run, linear probability model, where expected yi given xi is equal to pi, which is alpha I plus beta xi. Here we can measure the marginal effect directly because it's a typical OLS model. We are running the model directly where you can typically interpret like this, no problem. 1 unit change in kids age less than 6, then the probability is 0.16 decreases in the labor force participation of the married woman. So this is not woman, married woman. Okay. But the problem is actually the UI does not follow a normal distribution, and because of that, your YI is not a continuous data, and which is a so therefore your UI is a discrete distribution. Okay. So let us see how we can run using the logic model because of the limitation given in the linear probability model. So for the logic model, you just have to type logit and you can run the same function. So now this is a logic model. Okay, so when you moment run the logic model, the results is entirely different. When you run a simple OLS model, this is a simple OLS diagnostic where your F test is a overall significance. Okay, and your R square is given, and this is your ANOVA model of your table, and this is the interpretation. Here the marginal effect is directly captured. Okay, and here the t test is given. Here you see the difference is z square, the difference is pseudo R square. Here the distance is R square. So what is pseudo square? I will explain moment. And here you are looking at the F statistics, the overall significance here. But here in this case, you have a log likelihood ratio based on the chi-square distribution that is given. So the basic diagnostic test given in the logic model is entirely different from the OLS based model. Okay. So why? Because of the different variable which is a qualitative nature that are included in the model and which is again based on the sigmoid distribution framework, right? So the S curve. So there the PI we are having like 1 by 1 1 plus e to the power minus zi framework. So your alpha and beta, the coefficients are not directly captured but captured very indirectly based on the odds ratio, that is pi by 1 minus pi, right? So that's the odds ratio that you are capturing. So here this is a coefficient you are getting it. So can we interpret the coefficient directly? Can we interpret the coefficient directly? Here this coefficient is nothing but your pi by 1 minus pi. Okay, so it is not the unlike the OLS where you can able to capture the marginal effect directly. In the logic model, you cannot able to capture the marginal effect directly. Rather, this will gives only the log of simply decrease in the number of kids below 6 years of age, where 0.81 unit decrease in the probability of labor force participation for the married woman. Okay, so here you cannot capture the you cannot interpret directly using these particular coefficients. We can also see how that is actually different. So this is a coefficient, the direct result of a log of pi by 1 minus pi. Let us see the odds ratio. Logistic. So you see this is the odds ratio, pi by 1 minus pi, which is nothing but 0.4435. Okay. And you see the results are all same. There is no any differences in the results. Only thing is given the odds ratio here directly. And this is a log of odds ratio. Okay, so that is the differences. So now, because it is a odds ratio, we cannot interpret directly as given in the linear probability model, where we are simply directly interpreting the coefficient. So there is a we have to from this we have to capture the marginal effect. So the simple code is MFX. So here MFX, you are actually trying to capture the marginal effect after the logistic regression. So once you run the regression model, after running the logistic regression model, you have to recalculate again the marginal effect. So the derivation I'll show you in my PPT, but what I'm trying to show here, you see the coefficient. So this is the coefficient that you have to interpret rather than this value or this value. Okay. So here now you can actually interpret that every 1 unit change in the kids ratio, the probability of married working woman go to the labor force will come down by 0.19. Okay, so here again you see the marginal effect after logistic also shows the predicted the probability of they have the expected y hat. So the expected y hat is nothing but your 0.58. So this is the mean of the probability that so this is the base that you have to keep when you are actually interpreting this one. So that I will show it in the PPT. So here, this is a probability function that we have. We are actually trying to calculate through 1 by 1 plus e to the power zi, where your z is alpha I plus beta xi, right? So here we are not actually directly capturing the marginal effect. Rather, you have to find the marginal effect using the partial derivation. So the partial derivation of p with respect to x is beta I into pi into 1 minus pi. Okay. So your beta I. So your beta I into pi into 1 minus pi. So therefore we have to find the marginal effect after running the logic model. So that is what actually I have given here. Here this minus 0.8129 is already we find, right, in this regression. When you run a logic model, we already got this beta coefficient, right? Now this one into pi, the probability value that we already find minus 0.588. So you just apply that formula minus 0.81 into 0.58 into 1 minus, you get the value 0.196. Okay. So the 0.196 you get only by applying this derivation. So it means you are not getting directly the marginal effect, but you have to find the marginal effect after running the logic model, and you have to find the partial derivation with respect to the xi using this formula. Okay. So that the stata command with the m of x will directly do it. So that's how you are getting it. So in case of a linear probability model, your marginal effect is directly given, whereas in the case of a logic model, you have to compute the marginal effect. Okay. So here the PI is nothing but the average individual. So this is the average individual probability 0.58 based on the estimated probability. Okay. So the expected YI for that, the average individual probability is 0.58. So that is the base that you have to keep here, and you have to calculate for your marginal average married woman labor force participation. So you are actually now finding the average married woman. So what if there is a changes in kids who are below the age of 6? What is the average married woman participation likely to change? So you are trying to find the average married woman effect only from this only. Okay. So now there are two things also we have noticed in this equation, typical equation. One, what is this iteration? So this is the iteration of your maximum likelihood estimation, which is your iteration 0 log likelihood minus 0.514, where you don't include any other independent variable. It is only your probability value, okay, dependent variable. And you are adding 4 independent variable, right? So this is a iteration for one independent variable. This is iteration adding 2 independent variable till you have 4 iteration, because you have included 4 iteration, 4 independent variable, right? So this is your typically a total sum of square. So this is model with without any independent variable. This is a model with all the independent variable that you are included in the model. Okay. So now this is a clue. From this iteration only, you will be calculating the pseudo R square and the log likelihood ratio test. So let's see that quickly here. So typically your logic model basically log of pi by 1 minus pi, right? It's a odds ratio, log of odds ratio, which is a function of alpha I plus beta xi plus ei. So your conventional goodness of fit, which is explain sum of square by TSS, right? So if this is the data that you have, and this is your mean of your expected yi, and this is your observed data, right? So then your TSS, this is the total sum of square, and this is explain sum of square, and this is your RSS. So your formula for R square is typically ESS by TSS, or 1 minus RSS by TSS, right? Now, can you, if you apply this in a model where you are having a qualitative data, so your typical quality data occur either 1 or a 0. So in this case, what is actually happening? The scatter plot is not properly scattered, right? So it is either in the 1 or in the 0, because it is a qualitative response model. Okay, it is not actually ranging between 0 to 1. Your R square always range between 0 to 1. What is your data itself having 1 or a 0? Then your R square no longer valid. Because of that reason, you cannot apply typical R square in the model which is having qualitative data as a dependent variable. Okay, so how they are again capturing the goodness of fit in the logic model? So that is where they are calling as a pseudo R square. So how they are capturing the pseudo R square? Now you know the TSS. So this log iteration 0, which is nothing but log likelihood, is nothing but your TSS, because this is not including any of the independent variable. Okay, so that is your base L0, and iteration 4 is the log likelihood with including all the independent variable, which is nothing but your RSS. So that is a minimum, that is a maximum probability that you will be getting it to find the set of parameters when you include these 4 independent variable in the model. Okay. So when you apply that in this formula, 1 minus RSS, which is L1, and your TSS is L0, and you apply, you will get 0.14. Okay. So since it is, you are not directly capturing the R square because you are having a qualitative data as a different variable, you are trying to find based on the log likelihood, this value. Okay. That's why it is called a pseudo R square. Okay. So instead of finding a R square in a logic model, you often find a pseudo R square, which is calculated based on your log likelihood ratio. Similarly, for in the typical OLS framework model, you have a F statistics, which is the overall significance of the test. It is again based on your R square, including the degrees of freedom, right? Including the degree of ESS by TSS, where ESS is 1 minus R and TS is 1 minus N. So N minus K. So N is number of observation minus number of parameter, where TSS is N minus 1, number of observation minus 1, right? So, but again, since you are not applying that typical formula here, you will be using this L1 and R. Your overall significance for your logic model will be based on your likelihood ratio. So your likelihood ratio is calculated typically 2 into L0 minus L1. Okay. So L0 is minus 514.8732 minus this. You can get a computer log likelihood ratio, which actually you are comparing with your chi-square distribution with the degrees of freedom, the number of explanatory variable that you have. So in this case, you have 4 explanatory variable. So you'll be having a 4 explanatory variable in the model. So through that, you are trying to find the overall significance of your coefficient that you are having it. Again, here you see it is a typical Z. When you run a typical OLS model that we already run here, you are having a t-square, right? Sorry, t-test. So in the simple OLS model, you will get a t statistic. But when you run a logic model, you will get a Z statistic because it is asymptotically normally distributed only in a large sample. Okay. If you are having a small sample, your logic model will not work. And that's why it is following a this typical Z statistics, which is basically for a normal distribution, asymptotically normal large sample. Okay. So because of that, your Z statistics, you are actually having it. So there are 3 difference. One, your typical F statistics, you are not using it in the logic model. Your usual R square model, you are not using. Instead of you are using pseudo R square. And instead of a T statistic, you have to go for a Z statistic. Okay. Now let us see some more example using the probit model. So the probit model, again, the same here. Instead of logic, you just simply type probit. So this is a probit model. The interpretation of all this are all remain the same. Only the distribution, as I told you, that f of x function, that cumulative distribution function can be of a logic model or can be of a normal distributions. And again, based on the probit model, if you find the marginal effect, we will be getting minus 0.1961. So we get very marginal differences between the probit model, minus 0.1961, here minus 0.19688. So now there is not much differences in this particular interpretations if you compare both interpretation, but how you decide whether to go for a logic model or the probit model. Okay, so when your observation, for example, now you have a probability, you have a distribution of that particular individual owning a car and not owning a car, right? So now if the individual who are owning a car are only 10%, then remaining 90% are not owning a car. You are almost in the either one of the upper bound, right? So if you are say one owning a car, you are in the upper 90% of the upper limit. If the only 90% owning the car and 0% are not owning a car, then you are in the lower band. So the majority of the people, whether they are owning a car or not owning it, if you are interested to see that one who are owning the car and is only 10% only, then you are in the upper bound. If the majority of the people are owning a car, about 90%, that means maximum number of people who are owning a car, then you are in the that means it is actually between the occurrence of the event, whether the probability of the occurrence of the event, whether in the lower band or the upper band. If it is very high, then you can go for a logic model. If the probability of occurrence of the event is almost closer to 50%, that is, then that particular equation, I'll just simply show you the graph. So here, typically, if the probability of occurring the event is somewhere close to this 10% range in the lower band and the 10% range in the upper band as per the data, if you have the sample more like that, then you have to go for a logic model. If your probability of owning a car is almost in the range of 50%, that means in this range, both your probability, the probit model and typical logic model will give the same results. The differences comes only when in the lower band, upper band and the lower band. Okay. So if there is any differences in the lower band and upper band, the probit model and logic model will vary. Otherwise, if it is in the almost in the middle of the range, the probability of whether individual is owning a car or not owning a car is in this particular range, then it is almost both probit and logic model will be the same. There is also a lot of advantages in terms of applying this, because here you are actually trying to find a set of parameter. Okay. So what is set of parameter? Now we have the typical model where now given that the kid is having lesser than years, you have 0.19 decrease in the probability of married women who go to the labor force participation. Okay. Now assume that let us run the same model. Okay. Now assume that the probability of the kids who are at the age of less than the age of 6 is 0. So what will be the probability? If that means the married woman who do not have a kids lesser than 6. So what will be the probability that he will be going to the labor force? That means you are actually influencing, you are actually altering the set of parameters by using the marginal fixed effect, this particular variable. This particular, you are actually computing it MFX compute at kids below age of 6 is equal to 0. So you are now trying to find what if the kid is lesser than or below 6 is 0. If there is no any kids less than 6, then what will be the factors that determine the married woman go to labor force? So if you try to find, earlier it is used to be 0.19, right? The marginal effect is 0.19611. So it actually shows that if the married woman who do not have kids less than age of 6, then the marginal effect is actually
Right,
coming down.
just a
It is
minute.
not.
There is a request.
Yes.
They want you to make a full screen because they are not able to see.
Full screen?
Yes.
This is full screen only I'm showing.
Okay, ma'am. Nirmala ma'am, I think it was.
No, sir, whenever you are showing your PPT, at that time, if you can make it full screen, so we can see it properly. Yeah.
Okay.
Yeah. Thank you, sir. Thank you.
Okay. So here what I'm trying to tell you that here actually you are trying to see the marginal effect by keeping whether the kids who are below age of 6 is 0. So if whether the kids below the age of 0, whether that is actually increasing the probability of the woman going to the labor force compared to the keeping the kids who are lesser than 6 in the model itself. So that is what you are actually influencing here, marginal effect, keeping your kids below the age of 6 is equal to 0. So compared to the previous interpretation here, minus 0.196, here the probability of not going to the labor force participation is much higher than little lower here. That means if the married woman do not have the kids, it is more likely that they may go to the labor force participation compared to the married woman who are having the kids lesser than the age of 6. Okay. So here that is the flexibility because you are keeping the set of parameter you're just trying to check what if that kids number of kids also. So for example, number of kids, now I written 0. What if the number of kids lesser than age of 6 is 1? Similarly, you can also increase, maybe like 5. Suppose if we keep 5, what is actually showing? Let's see. So kids is equal to 5 minus 0.02. Okay, but the overall, this is I'm randomly trying, but the overall model itself not perfect. Actually, a lot of the insignificance is coming. But otherwise, you are actually trying to interpret by actually trying to see what if that the kids is equal to 0. Number of kids who are having lesser than age 6 is 0 versus the kids having number of kids who are lesser than 6 is already whatever the data as it is. So when you are trying to manipulate or trying to change the observation, what if the kid is less than 6 is 0, whether it motivates the married woman to go for a labor force or not going to the labor force. Similarly, even you can try to see in terms of education also, what if that their education level increases, whether will it increase the probability of married woman to go for a labor force participation or not. This is more like a policy framework where you can also try to see what is the major factor among this particular variable influences heavily on the factors that are deciding the married woman to go to the labor force compared to the number of kids having less than 6 age, whether the education or the experience or the husband wage. So this also you can compare by trying to see it using the logic model. So there is also other model, Tobit model, but basically in the Tobit model, again, this is a typical qualitative model only. I did not show here. I thought I don't have much time to show it. I stopped with the Logit and Tobit model. But in the case of a Tobit model, you actually often want to find if at all he own a car, what are the factors that actually motivated him to own a car, given even though the income is given. So now here you are actually more concerned about the 1 rather than the 0. So if you are keeping the dependent variable 1, you cannot likely run any model, right? You have to include both 1 and 0. And here it's the typical regression model framework we are running it, but in the Tobit model you are concerned more about 1 and not about the 0. So that the distribution and entirely the interpretation also will be different. So here you are trying to find the probability of the individual whether own a car or not owning a car given the income changes. But there, why the individual is owning a car? That means you're emphasizing more on the 1, not on the 0, and trying to find the reasons for why he is owning a car. So there, the interpretations, it's entirely focusing on the 1 itself. So there also you will be running this qualitative response model, but there the applications is a little different. So with this, I conclude, and if you have any doubt or any clarification, you can please discuss. Thank you so much.
Thank you, Dr. Zoe. So participants, friends, if you have any questions, please ask ourselves.
Sir, may I?
Yes, please.
Yeah. So in Logit, we are using binomial distribution, and Probit we are using Poisson. Is it?
In the in the Probit model, actually it is based on the normal distribution. So that's what in the PPT I was showing you the cumulative distribution function. Either it could be a logistic distribution or it is in the normal distribution. So the distribution function could be of anything. And that equation, the framework that is keeping for f of x It could be of anything. If it is a logit distribution, then you will be having a logit model. If it is having a normal distribution, then you'll be having a probit model.
Any more questions? Participants?
So what is the major difference in the probit and tobit? In there we are saying our focus is on the positive value, that is the happening of the event.
Yes. No, I actually did not cover the tobit model because I thought I don't have much time. Almost I completed close to. So that's I emphasized only on quality response model, logit and probit. Typically, the probit model or a logit model, you're trying to find the between 1 and 0. So whether the firm, whether the individual is owning a car or not owning the car, what are the factors that determining the individual whether to own a car or not to own the car, given the level of income.
Sir, in logit, when we are saying the cutoff is always the middle 50%,
Okay.
or we can set
So
the other
trying to
cutoff also.
what are the not necessarily depends upon the distribution that because your outcome is already there in your sample. When you collect the data, you that number of 1 and number of 0 is already given. If it is at the higher end, accordingly that distributions will be varied. It's not always necessary that it is 50. So even if you, in fact, if you see that the predicted probability value I've shown in the PPT, just a minute, share the screen.
Any more questions?
Yes, sir. So, like you also said that if the probability is near to 0 to infinity, then only logit model will be applicable, not the probit one.
0 to
infinity.
yes.
Only the logit model will
You
be
see
applicable.
both logit and probit. You see that is the difference between the linear probability model and the logit or probit model. In the logit model, because it is assuming a linear probability in nature, it is having a straight line. But in the probit model, the probabilities range between minus infinity to the plus infinity. Okay. But in the upper band and the lower band, that is in the both, it is remained constant. That is why the S curve goes like this. Okay.
Okay, sir.
So because of that, it remains constant, and the major changes actually happening between the middle range of it. If you see that curve, I've seen it. Here, this is the part where the distribution remain constant, but the most of the probability changes in this particular point of time. Okay.
Okay, sir. Okay.
Your Z, as Z is nothing but alpha I plus beta I, ranges between minus infinity to plus infinity, and your probability changes between minus infinity to plus
Okay, sir.
infinity.
Okay, sir.
So in the linear probability model, it's either 1 and 0. So either 1 or 0. But you are trying to find the probability of that various depends upon changes in the given income or given the xi. Okay. So now you are converting the discrete series into a continuous series by finding the changes in the probability.
Okay, sir.
And for both probit and logit, this the framework is still the same. Only thing, the cumulative distribution function, whether it is a logistic distribution or a normality distribution, that based on that will change. So if you see here, the framework is almost same. Only in this f of zi, whether it's based on the LPM or a cumulative distribution function of a logit model, or it could be of a normal distribution. Okay. Accordingly, the shape of this
Sir, are
S
you
curve,
showing any screen?
sigma.
Because I'm not able to see any screen.
I did not share the screen. Okay, sorry.
Sharing any screen, madam. You're not sharing any screen. Or is
No, I am actually sharing the screen. I cannot open my WebEx.
okay, it's not visible here.
There is some technical error. I cannot open my WebEx section. Can you stop the sharing the screen from your side or anything?
No, you have to stop, Durai. We are not doing anything. You have,
I
otherwise, you
cannot
can
open
just
my WebEx section.
leave the meeting and come back. Join again.
Okay. I hope you can see my screen now.
So yes, sir.
Yeah. So this is what I'm typically telling you. The linear probability lie either 1 or 0. But the logistic distribution where you have the variations in the the continuous series of probability. So given the change in the x, your probability will change. But only it remains constant in the lower bound and the upper band. Otherwise, it always changes. And this typically follows the distribution, cumulative distribution function, whether it is following a logistic model or a normal distribution. That curve, what we are having here, little bit different. Otherwise, it is more or less the same.
Okay, sir.
So that is why in this range, you both logic model and probit model gives the same results. Okay, but in the case of logic model, given that your observation where the occurrence of event either in the upper bound or the lower bound, accordingly that will change it. If it is in the upper bound, then you have to go for if either in 90% of the observations lying closer to the 1 or the 90% of the observation lying closer to the 0 somewhere, any of this reason, then you have to go for a logic model. If your observation is distributed more or less 50 to 60 or 80 that range, then your logic and probit model will give the same results.
Same results. Okay, sir.
So it's all about the distribution of your that occurrence of the event given in the dependent variable.
Okay, sir. Okay. Thank you, sir.
Thank you.
There are a few questions are given in the chat box.
Okay, I'll read it.
Right.
So which is better, logic or probit? So this is what I was telling you. If your the dependent variable, that 1 and 0, that is a dummy variable that you are assigning, right? Like binary response variable. If it is almost 90%, something is either 1 or your 1 is 90%, something like that, then you have to prefer a logic model because the distribution is itself mostly in the upper bound or in the lower bound. If the distribution of the 1 and 0 is more than 80%, it's almost closer to 50%, like 50% of the occurrence of the event is 1 and 50% occurrence of the event is 0, something like that. Your both logic and model, probit model will give the same results because of the S-shaped curve where that middle range where both probit and logic will not give major differences, very marginal. That is why even in the data exercise results that I showed you, the changes is very marginal. What if the married woman labor force participation, the married woman who are entering to the labor force, it's almost 10% only. The remaining 90% are not going into the labor force. So it is almost skewed, right? Either in the upper bound or lower bound. If it is what you are calling 1 for a married woman who are going to labor force is only 10%, it is in the upper bound, right? So in this case, you have to apply a logic model. But since it is more than 30-40% of the distributions are entering to the labor force participation. That means in this case, typically either logit or profit model that you can use, no problem.
Just look at the first question, correct? You can scroll it. Let's scroll up.
Okay.
Somebody
But
asked,
I cannot see. Maybe I closed and opened.
okay, I can
cannot
tell
see.
you.
I'm seeing.
Some people ask, does sample size matter while choosing logit or profit model?
Ideally, for both logit and profit, since it is asymptotically normally distributed, that means only it valid only in the large sample. So both profit and logit, you should have at least a large sample to run your logit or profit model. Otherwise, your model may not be very efficient, asymptotically efficient. So to have an efficient model, you should have a large sample for both profit and logit
The
model.
next question
But
is,
the differences comes only in the different variable, the distribution of the occurrence of the event, whether it is skewed or it is almost in the distributed equally.
the
Okay.
next question is,
The occurrence of the event is more like 50 or 40-50% something distributed equally, then it is good. You can either run both logit or profit. Otherwise, if the occurrence of the event is skewed towards either towards 0 or 1, then you prefer a logit model. Otherwise, the sample size should be large in both logit and profit.
yeah, the next question is, can we perform the same analysis through spaces? Whatever you did instead,
Yeah, in SPSS is very popular because SPSS is popular for this quality data analysis, where you get even more sophisticated. All these options are there. It is basically user interface. You can still do there as well, no problem. All the leading statistical software have this model. If it is a user interface, you have all this option in the menu box itself. If it is a coding based like R, you have to know the coding to appropriately.
Yes. Any
results.
questions? Okay. If you don't have any questions before closing the session, I just want the participants to be stay here for 5 minutes once the resource person leave. Okay. Yes. Anvesha, over to you.
Yes, sir. Thank you. On the behalf of my university and the entire Department of Economics, I extend my hearty gratitude to our honorable speaker, Dr. Durya Raj, for enlightening us with his knowledge and graceful words in today's workshop. Personally, it has been a very enriching session for me. It has been a tribute to host all of you participants and the audience. I'm thankful to the entire department and the audience. With this, this is Anvesha Goswami signing off. Thank you. Take care.
Yeah. Yeah. Participants, you can stay. Durai, I will call you, man. Thank you. Thanks for your time and.
Thank you for inviting me, and also thank you all the participants who are listening patiently and asking.
Yes. Actually, I want to make a special
questions
thanks because I pre-poured the session. You accepted it. Otherwise, the program may be completely messed up. I have to understand there is a lot of pain in making presentations before a committed day, but still you did it. It's a great presentation. Thanks a lot. Once the presentation is over, I will give you a ring. Okay. Thank you, Doctor.
Thank you. Thank you so much. Bye. Thank you. Thank you all.
Yes. Participants, am I audible for all?
Yes, sir.
Yes, sir.
Yes, actually, I think most of you might have received that web link I shared to which the Google form which I shared. The purpose of sharing that Google form is to get your email address to share your materials. But as of now, I found 67 people here. Today, there are some 80 people are joined, but as of now, I received only 31 responses. So I will share materials to them only. Okay. It means that most of you are simply presented here with the mobile and there is no physical presence. Just simply you joined and left it. So don't blame me. I will share the materials to whom I received the mail IDs. That's all. Okay. Got it? All of you?
Okay, sir.
Yes.
Okay,
sir. Okay, sir.
Whomever registered, I will send the mail. That's all. Okay. Not to the mail ID what you have shared because I already told you There are 200 participants are registered. Only 120 are in regular visit. Out of that, now it's become 80. Okay. So even 80, I don't know how many of you really present here. Only I received.
Can we register now, sir? Sorry.
Ma'am, it was shared some 1.5 hours back. It means that
Yes,
you are
sir.
joining.
Yes, sir. I didn't do that at the time.
It means that you are joining now only. You are not here.
I was there.
Twice I
I was
shared.
not able.
Thrice
Okay,
I
no
shared.
issues.
You check the chat box. Twice I shared. Means that you are not here. It's a very simple idea. See, I already told you it is not a certificate what you are going to get from this program. It's a knowledge. Okay. But I don't want to comment anything on that. Anyhow, I will share once more.
Yes, sir. Yes, sir.
See, one more thing is I blocked the group. You can't post any messages. You can't share it to anyone. Unless until you registered here, you can't share the thing. So I will share the materials to those only who registered in this Google form. That's very clear. Okay. Yes. The second thing is we have some 10 minutes. So tomorrow is your exam. So I will just give you a small note on your exam. It's going to be MCQs. Probably I'll go for 30 questions. From each session, I can take 2 questions each. So from each section, you can get 2 questions. So 14 sections. So it's going to be 28 plus maybe one on extra. Total 30 questions, right? Any questions?
What is the pass marks, sir?
Actually, sir, there is no pass mark. If you are supposed to take more than 60% in the exam, there is no pass or fail here.
Okay, sir. Thanks.
Okay. That is what Atal is referring, sir. You have to have a minimum 80% attendance. Then you are supposed to get 60 marks, which means that if there is 30 questions, means you have to score more than 18. Okay, I'm not going to ask anything new. Whatever, actually, I'm getting the questions from the resource person. So they will share the questions. My role is just a facilitator. I just simply fill it in the Google form and share it to you. That's all. Okay. If you have,
Yes, sir.
Yes, if you want to have any questions as of now, the discussions, what happened, any queries, you just forgot to unaddress. If you forget to address, I can help you. If you have anything to ask, you can ask on any topics. I'll try my best to solve it. If you have anything, or otherwise, this is the only thing I want to share. So I will share the PPTs. I get to receive the PPTs from today's resource person. Only very few resource person was shared it. So whatever I get it, I will share to these people. Okay. Even I can share the link of your exams only to these people who registered for tomorrow, not to all. I already told you 200 participants are registered. So it is not wise to ask everyone to join, right? Please understand the concern. Yeah, even now 67 are here. How many participants I'm only getting now? It's 47. It means that most of you are just simply join and doing other work.
Hello, sir.
Yes, ma'am. Please.
Can we get the recordings of the sessions, please?
Ma'am, that's what I'm saying. Ma'am, recordings is not happen. I'm not doing any recordings. Okay. You look at here.
Actually, I was there for all the sessions, but since all the topics are totally new for us, so it would be helpful in future. Nothing else, sir.
Yes, ma'am. I understand, ma'am. Look at here, ma'am. In the top of your screen, it says that
Yes,
now
yes,
today
yes.
we are recording 8.5 hours of videos. Okay. Just I can't share the entire thing. Okay. So I have to edit it. First point. Second point is I don't know how to share it. So I can upload it in the what is that? A channel. I will give the YouTube channel link. Okay. Whenever you feel free, you can upload. You can see it. Okay.
Okay, sir. Thank you.
It can be uploaded in the channel, but not now because it needs some editing. I think you might have seen this 8 hours into 4 days. So almost 24 hours of videos. We have to edit it.
Yes, sir. No problem, sir.
It's a painful thing. Okay.
Yes, yes. Thank you.
Okay, ma'am. Any
Sir,
questions?
you can share that link of the Google Drive where you save the videos, like if not the channel.
Google Drive will have only 15 GB, right?
Okay, sir. Okay.
You have to understand that part also.
Okay.
They can upload on the actually, technically, I have to give the only link to Atal. Okay, that is what my earlier FDP resource processor did. Okay.
Okay, sir.
So,
Okay, no issue.
don't worry, that will be in the channel. You can make use of it anytime. Instead
Yes, sir,
of,
because this time the resource persons are teaching very well, and this is very helpful for us in future also. That is why we are concerned.
Yes, ma'am. Actually, this FDP is all for you people only, not for me. Okay.
Okay,
Everything is
thank you,
open.
sir.
Everything is all for you only. But the only problem is if resource person shared to me, I will going to share it. As I said, I'm just a facilitator. I'm getting here and share it to you. That's all. Okay.
Thank you, sir.
So you have any questions regarding your questions, tomorrow's exams, or any queries on the topics what we discussed? You are feel free to ask now. I will be available for 10 minutes. Anything, any clarifications required, I can tell you, and then
What would be the platform for the paper?
Google form. Now I'll
Okay,
tell you, the question papers will be shared, Google form will be shared only after your valedictory is over. Okay.
Okay, sir.
Then only if you attend the valedictory, based on that attendance only, I can enable your feedback link. Unless until you are not submitting your feedback, your certificate won't be released. Not by me, it's by FD, it's by Atal. Okay. You have to make the feedback in their portal only. Unless until I gave the attendance, that portal won't be open for you. Okay.
Okay,
At least make yourself available for tomorrow, full session. You have to attend the valedictory, then only I can enable your this exam portal. Once it is over, then only you can I can upload your attendance to the portal. Then only your feedback form will be operatable. Once you fill the feedback form, then only you can get your certificates and attendance. Is it clear?
Yes, sir.
Okay, sir.
Yes.
Sir, will we be getting the examination link to the mail ID listed today?
No, not this one. Tomorrow also I'll go for a new one.
Okay.
I can compare actually. I have your attendance with me. So who is having more than 80% attendance, then only, even though you attend tomorrow, it's purely based on the entire attendance period, because it's mandatory that you are supposed to have 80% attendance. All your records are supposed to be submitted to Atal. They will cross check it. Sometimes it's going to be a problem for me. That's what from the day one I'm saying. Try to be here. Actually, we have a mechanism which will capture what time you are joining and what time you are leaving. Okay. How much time you are in the presence. Based on that only you are permitted to write your exams. If you are not having that attendance, automatically you won't get the link.
Okay, so automatically it will be coming to my mail ID, right, sir? If my attendance is there, if I am having the
yes, sir. Tomorrow also we'll get your mail ID again, because I told you no. Even if you want, I can show you. There are 200 participants registered. I have 200 email IDs. There is no point in sending to all, right? They're not ready to write the exams. Why we have to? Sometimes what happens is these people will join and write the exam also. MCQs they will pick up. Luckily they'll get a good marks also. We have to give preference to those only who are very serious. Otherwise, it's going to be pure formality, right?
Okay, sir. Okay.
Yes. Any questions? So tomorrow we have 4 sessions. I think you would have looked at the schedules. Okay. The break in the second half is only half an hour, because we have to finish the valedictory session. So all of you try to be present, right?
Yes, sir.
Okay, sir. So shall we leave now?
Yes. If you don't have any questions to ask, you may leave. You may take your leave.
Palas, have one question.
Yes, ma'am, please.
Yeah, so today's cancelled session on the econometrics use in research. So any chance then we get some insight about that?
Yes, ma'am. Actually, the plan is, to be very honest, that is supposed to be teach in the second session, ma'am. What happened is the resource person has some problem. So that is what I shipped that yoga session. Actually, the yoga session was planned today as by schedule. Okay. I want to give you some time, but because of the non-availability of resource person, I shipped the session to on Monday. He said that he will handle the session on today, but unfortunately yesterday he said that he is not in the position to deliver. So I skipped the session. I have another resource person. Tomorrow is going to be very interesting research platform, because what I felt now is even I can handle session, but the problem is now it is not. This is not the right time to discuss about that issues. It is supposed to be discussed at the very beginning. Now if somebody talks about econometrics, its role, statistics, mathematics methods, you get bored. Okay, you people have more information than that. So what I felt is tomorrow I'm inviting a person who is dealing with this NSOS data. Okay. So what is the problem in dealing with, as of now we are looking only time series models, right? Tomorrow we have sessions on cross-section data. Sometimes SEM and all. So tomorrow we are having a resource person, someone called us Mohammad Siddiq Chekaria from what is that institute? Gulati Institute of thing from Kerala. Okay, he's a renowned person. He's going to talk about on how to deal with NSOS data.
Okay, yeah, that's why, because I was looking forward for that session, because it will be interesting to know that how can we use in different areas. Yeah.
Yes, ma'am. Actually, even that is what my plan is all about. That thing is nothing but it will tell you how you're supposed to approach a research, economic research. People will actually, it's a kind of entering into the movie in between without knowing the first part. Because the last part we want to do research. But the session, what I planned was it will give an idea where you're supposed to start, how to approach the research issues, how you're supposed to approach the mathematical models, how you're supposed to approach the equations, then how you're supposed to convert in the econometric model, then how you're supposed to choose the model. Those are the things I planned in that session. Unfortunately, it's not happened. Now I think it's too elementary at this level. If you want to be very particular, I don't have any issues. If you want to hear during the break time, I can give you some insights. It's up. It's open. Okay, it's not a mandatory session. It's if somebody is interested, I can do a small note on that.
Yes, sir. Yes, sir. I would be interested in that.
Then fine, ma'am. So maybe some 20 minutes after the first session, I can talk about that. I
Sure,
have more
sir.
slides for it.
Yeah, sir. Yeah. Thank you
Sir,
so
I
much.
do have some doubts.
Yes, ma'am. Yes, please.
No, sir. If you're willing to give your a little bit of your time, so we can discuss at that
I don't
particular
have any
time.
problem, man. I'm open. Please.
Sir, actually, I was planning to have a paper on this GSDP of these states and about forecasting about these.
Rahul, just a minute. Can you speak a little louder? Your voice is very low.
Yes, sir. So I was saying that I am basically new to this time series. I have done work on cross-sectional a little bit, but I want to uh, publish a paper on time series data and that too on the GSDP. I have this crux in my mind, but I'm not sure how to move forward in this context. Like I have to check the stationarity of that data and I have to get that quarterly data for the forecasting, but how to perform that univariate analysis in this context.
Rahul, actually very simple. I will tell you in a very simple way. I can try to explain economics in one single line. See, you have a data, okay? You don't know the nature of the data, what type of data it is. Let us assume the time series data. I'm not talking about the frequency of the data. I'm talking about the properties of the data. Suppose you have a data. I don't know how many of you remember. In the first class itself, I told you the data is supposed to speak for themselves, which means
Yes,
that
sir.
it is supposed to tell you what type of model you are supposed to apply. Okay. So you have a data, you don't know anything about the data, but if you have something in your mind, you are not sure that the data can possess that nature. So what you're supposed to do is the basic step of any analysis, you have to check the stationary property. Okay. Then based on that stationary condition only, you can decide what type of model you can use. As Raja sir pointed out, if the data is stationary, then you can think about a set of models, completely new set of models. Okay. If the data is non-stationary, then you have only co-integration models, right? So what are the models you can apply if the data is stationary? If the data is stationary, then you can go for even the simple regression. If you want to run, you have to make sure that the data is stationary. If it is not stationary, then it is going to be called as spurious regression, right? So generally, what we used to do is we pick some data without checking any property. We run the regression. Even that is wrong in econometrics. Okay. The first point. If the data is stationary, yes, you found that your data is stationary. Then you have to decide what is your objective. Whether you are going for forecasting or you are going for you are interested to check any causality relationships, or you are interested to measure the volatility of that particular variable. Let me tell you a small example. Suppose you have a data. For example, GDP data. Okay. If your interest is to check whether GDP causes public expenditure or public expenditure cross growth, there is a lot of theories on economics. Something called as in economics, there is an interesting theory advocated by John Maynard Keynes. Okay, there is another theory called as Wagner's law of public expenditure. I'll tell you a small sentence. What Wagner, Adolf Wagner is a German mathematician. What he's trying to say is that if you have more growth, then you can go for more expenditure. That is the idea of him. Or you will understand. He proposed a theory which says that if there is more growth, then you have more expenditure, right? This is his theory. That is, which means that if more GSTP means more expenditure. That is his idea. On the other hand, Keynes says that it is not more growth. If you have more, if you spend more, then you have more growth. It's an ulta way he is saying. Okay. If you want to check whether GDP causes growth, GDP causes expenditure or expenditure causes growth, your objective is to check the causality, causal relationships. Then you have to think about some model called the Granger causality test. Okay, there are n number of causality tests are available, so you can think about those models. So if you are interested in checking the causal relationships or some kind of nexus between two variables. You can think about that. Let me
Actually,
finish.
I was thinking about forecasting, but I
Yeah,
too
so that
have
is what
data
I'm coming.
available.
Yeah,
I
I'm
have
coming to
to.
that. I'm coming to that. Okay. Suppose if your interest is to forecast a variable, okay, suppose you want to forecast what is going to be the variable of what is going to be your GDP for the next year, there are a few possibilities. One is you can forecast the variable in the ARIMA model. Okay, you can fix a AR model, you can fix a MA model, or you can fix a combination of both. Okay, the advantage of this is no need to bother about the dependent variables or independent variables because we don't know what are the variables exactly influencing your GDP. There may be n number of variables, right?
Yes, sir.
So instead, if you want to forecast a variable with only univariate setup, that is, you are going to forecast GDP only based on its own past lagged values, you can choose ARIMA models. Okay.
Okay.
But if you want to forecast the value of GDP with a set of other variables, maybe a group of variables, a vector of variables, or some other independent variables in the model, then you can think about a model called as ARIXMA model. Yesterday I told you, ARIXMA model.
XMA.
X is nothing but suppose you believe that GDP is determined by a variable called as
Investment.
taxes, yes, investments, capital. You can include that in the model. Okay.
Actually, I have data on investment, employment also of this particular state.
But
So,
the problem is, if you if you check this kind of information, then you have a problem of something called a simultaneity. Okay, if you look at investment, if you look at employment, your employment does not only influence your GDP. Meantime, your GDP also influences your employment. Or you will understand.
Yes, sir.
It's a two-way causality. So if you are using such a model with one single regression, then you end up with the problem of simultaneity. Okay. To overcome that, you are supposed to apply a different set of models. So instead, what I suggest is you can better forecast your GDP with the help of its own past lagged values. Okay. Otherwise, you can think about a war model where you can go for a set of equations. In war model, the advantage of war model is none of the variables is independent there. Okay. Why? Because in one equation, a variable x is independent. In the other equation, the variable y is independent. In the other equation, both x and y may be independent. So there is no dependent or independent variables in war model. Okay. So if you are very particular about that, you can think about those kind of models. It all depends upon researcher's objective. Okay. There is no any unique model for it. If you have different data, if you have different ideas, accordingly you can plan your study.
So being a new to this field, can I go with this only forecasting and univariate because I think it's the most basic.
What I suggest you is don't underestimate yourself that you are new. If you start reading, everything is available. Okay, it's nothing new actually, nothing tough actually. Once you started understanding, even though you estimate ARIMA, you might feel that you can do a better model. So just start with this ARIMA, then you may think about it. Okay.
Okay, sir. Okay, thank you, sir. Thank you so much.
Yes, thank you, Rahul. Any more questions? See, I'm a very fast speaker. Okay, so if you have any issues, please let me know. Put me a break everywhere.
Sir, have you used JASP for time series analysis?
Ma'am, generally, JASP, the problem is it's designed for only cross-section analysis, ma'am. Why? Because if you look at the time series analysis, you might have seen that there is a lot of equations behind it. Okay, you can't write all those equations by own. Sometimes you are really interested, you can do all the analysis in Excel itself, but you have to make sure that you understand it properly. JASP is a software which is generally designed for the cross-section analysis, where you are coding and recoding the variables into different phases.
Sir, one more question. It's not related to time series.
Please,
so
ma'am.
nowadays, more focus is on qualitative data analysis.
Yes, ma'am. Actually, now even economics is some. As I already told you, nowadays economics is shifting phase from social science to behavioral sciences. Now there is a separate branch called as behavioral economics. That is what the Nobel Prize is given for last 2 years. Okay, so people try to assess the behavioral pattern of the people because things are changing, keep on changing. Why this pattern is very important is I can tell you a small example. If I ask you which is your favorite movie now, you answer, right? Somehow, maybe in the morning 6 o'clock, yes, you are very happy to answer the question. Suppose you are watching the movie and I ask you which is the favorite movie, you may have a very what to say, you may share it with a very happiest moment. Okay. Sometimes if I ask you the same question by knocking your door at midnight 2 o'clock, what you can do? You may get annoyed, right? The same question, same person, different times. You respond in a different way. So now economics become purely behavioral sciences. They want to measure how people will react in different situations. So obviously they're using quantitative data. But the problem is here we have to make a lot of assumptions because it is not a kind of one-to-one relationship. Okay, a same person can react in a different way at different situations for the same input. So people are trying to measure it in the names of customized random trials. For that, which David Card got Nobel Prize. Brinda Madam also talks about them, right? But still, there is a debate that the validation of the results. Even David Card got the Nobel Prize. There are people who are still questioning his validation of the results. You can't control the things because here it is not one-to-one relation. As I said, it is not a laboratory science. If you add 1 unit of hydrogen and 2 units of oxygen, you can get water everywhere. Even if it's the US, even in the midnight, even in the depth of the sea, you can get it. But here in social sciences, it's not happened. So still that question is, that kind of research is questionable. Yes, ma'am.
Yeah, because in finance also the same thing is happening now. More and more focus is on qualitative, the behavioral finance, rather than the quantitative.
Yes, ma'am. The problem is in the behavioral finances, you can do only a cross-sectional analysis. You can't go for a time series analysis because in time series, the frequency of the data matters, right? Based on, it's all purely based on data generating process from which it's come up. Okay, it has its own setup. But in behavioral sciences, most of the data what we are talking, the techniques what we are talking may not be applicable. We have a different set. Even a simple table can tell you different stories in a behavioral science.
We are using more structural equation modeling in behavioral finance than the time series data analysis.
Yes, ma'am. In SEM, you are talking about something called SEM, right? In that is our SEM. In econometrics, there is a model called SEM. It is called as simultaneous equation model. As I said, see, the time series econometrics is generally designed for macroeconomic analysis, ma'am, finance and macroeconomic analysis. If you're looking for the macro data, okay, the data all together. Whereas cross-section, as you said, behavioral sciences is not designed for society as a whole. It may be for a specific group or kind of thing. So we are supposed to look for different techniques there.
Yes. Thank you so much, sir.
Thank you, ma'am. It's my pleasure.
Yeah.
Any questions? Okay, I think I am killing your time. So we'll meet tomorrow morning. Have a good day.
Okay, sir. Thank you, sir.
Thank you.
All. Thank you all.
Bye.
Thank you, sir.